Your Royal Highnesses, honoured guests, KAUST colleagues, ladies and gentlemen. My name is Professor Donald Bradley, and it's my great pleasure as the Vice President for Research to welcome you all to Day 2 of the KAUST Circular Carbon Initiative launch event. Today we celebrate and showcase the work of many KAUST researchers who have answered the call to redouble their efforts to address the global challenge of climate change. They are doing this through the concerted action provided by the circular carbon economy paradigm, which, given the urgency of the need, is appropriately technology agnostic, pragmatic, and outcome focused. We were delighted that despite his impossible schedule, His Royal Highness Prince Abdulaziz, Minister for Energy, was able to grace yesterday's launch, and his inspiring and motivational speech left us in no doubt that there was very much for all of us to think about and even more to do in relation to climate change. His Royal Highness very conspicuously led the effort over the past year to bring the concerted action of the circular carbon economy to the attention of the Kingdom and to convince the global community of its many merits, culminating in the endorsement of the Circular Carbon Economy platform at the G20 Leaders Summit on the 22nd of November. This outstanding achievement is testament to His Royal Highness's drive, diplomacy, and determination, for which we are all exceptionally grateful. It's been a great pleasure and an honour for KAUST to be able to contribute to this effort, especially through our participation in the Circular Carbon Economy National Programme Task Force, alongside many wonderful colleagues from the Ministry, from Saudi Aramco, from SABIC, CAPSARC, and our other partners. Our agenda for today covers first a recorded welcoming remarks from the KAUST President, Dr. Tony Chan, who will speak about the challenges of climate change and KAUST's commitment to addressing those challenges. We will then hear in person from Professor Jorge Gascon, the KAUST Circular Carbon Initiative lead, who will introduce the science and engineering details of the KAUST Circular Carbon Initiative and outline our strategic focus, comprising 5 thrusts that directly address the 4 R's of carbon management, namely reduce, reuse, recycle, and remove. Professor Gascon's presentation will be followed by a recording of our special plenary lecture, A Circular Carbon Economy, delivered by KAUST Distinguished Research Professor Bill McDonough. Bill is a practicing architect who has contributed enormously to rethinking economy in light of the global climate crisis. Following the Cradle to Cradle manifesto that he developed with his colleague Michael Braungart in their 2002 book, Cradle to Cradle, Remaking the Way We Make Things, Professor McDonough has been a very visible contributor to raising the debate on the circular carbon economy. In his talk, he will give a personal account of his involvement in sustainability over many decades and the reasons why he is so strongly committed to the circular carbon economy paradigm. We've just heard, and we're very pleased, Professor McDonough will be able to join us for questions after the presentation of his lecture. Then after Professor McDonough's talk, Ms. Nouf Iman, who's a Science and Innovation Advisor at the British Consulate General in Jeddah, will kindly introduce the new United Kingdom Earthshot Prize, recently launched by His Royal Highness Prince William, the Duke of Cambridge, which is focused on finding solutions to repair the planet by 2030. KAUST is very pleased to have been selected as one of the nominating bodies for this prize, and we are delighted to host Ms. Iman to give us an overview of the prize and the nomination process. We will then show the KAUST Circular Carbon Initiative video, produced by KAUST Global Branding and Communications, for which our thanks go to Mark Mulqueen and his team. And then after the video, we will start the tours of the KAUST Circular Carbon Initiative Expo. Part 1 will take in our exhibits on City of the Future, Farming of the Future, Nature-Based Solutions, and Closing the CO2 Cycle. Part 2 of the Expo will cover Nomad Desert Solutions, and Part 3, our Gas Station of the Future, in collaboration with Saudi Aramco and McLaren Racing Limited. We also have a series of live interviews being shown around the venue, and we will be broadcasting additional video footage that we hope our delegates will enjoy at their leisure. Before we commence the program, I'd like to offer a few observations on the KAUST Circular Carbon Initiative from the perspective of the Vice President for Research. The Circular Carbon Economy platform, endorsed by the G20 Leaders Summit, resonates fully with the vision and ambition of KAUST to tackle global challenges through concerted science and engineering action. We have the strong disciplinary background on which such initiatives can be successfully built, and we have been investing for quite some years in the talent and resources needed to drive forward a wide variety of technology solutions that address the 4 Rs. Our new Circular Carbon Initiative draws everything together in the technology agnostic, pragmatic, and outcome-focused manner that will be essential for progress. It also confronts us with the practical challenges of scale-up and deployment that we are enthusiastically embracing together with colleagues from KAUST's Innovation and Economic Development team, led by Dr. Kevin Cullen, and with our partners at Aramco, SABIC, NEOM, and many other entities. In addition, we scientists and engineers at KAUST must now step into the realms of economics and policy, and we very gladly embrace the opportunity to be mentored in this realm by KAPSARC President Adam Szymiński and his colleagues, and by our new KAUST colleague, Professor Bill McDonough. KAUST Circular Carbon Initiative, led by Professor Jorge Gascon, has enthusiastically answered the call initiated by His Royal Highness Prince Abdulaziz, and I trust that you will agree, following today's event, that the initiative offers a compelling contribution to reaching the goal of stabilizing our climate. Thank you.
Assalamu alaikum. Good afternoon. Your Royal Highness, Prince Abdulaziz, Your Royal Highnesses, Your Excellencies, honored guests, KAUST colleagues and friends. Thank you, Your Royal Highness, for honoring us with your opening remarks and for your clear vision of our collective pursuit of a circular carbon economy. Thank you, Vice President Donald Bradley and Professor Jorge Gascon, who will address us later, as well as other faculty members and staff, for your leadership and effort in setting up this initiative on circular carbon economy. Now, it's quite evident from the remark you just heard from the Royal Highness that KAUST, we call CCI, Circular Carbon Initiative, is our contribution to the Kingdom's Circular Carbon Economy National Program. We hope it will be a key contribution, an important contribution that itself, in turn, is a part of a global effort for lowering the greenhouse burden of the atmosphere, which is now enshrined in the 2020 G20 Leaders Declaration that just came out a few days ago, really a week ago. So allow me to reinforce an important point that His Royal Highness has raised multiple times in his remark we just heard, but also elsewhere. The problem is our changing climate, and the solution is captured in what should be a defining document of our generation, namely the Paris Agreement. Article 4 of this agreement urges all nations to undertake rapid reduction thereafter in accordance with best available science, so as to achieve a balance between anthropogenic emissions by sources and removals by sinks of greenhouse gases. The United Nations Environmental Programme's assessment is frankly bleak, as countries continue to miss their commitments to reducing greenhouse gases. And the so-called emission gap is widening. This gap, of course, is the difference between what we should and what we are doing in terms of reducing the greenhouse burden of the atmosphere. Now, a crucial piece that must be acknowledged and urgently addressed in order to narrow this gap is the removal of carbon dioxide from stack emissions and directly from the atmosphere. And this is why the Circular Carbon Economy platform in the G20 Leaders Declarations is really a game changer. Put simply, the Kingdom of Saudi Arabia has stepped up and decided to lead And KAUST today is making a commitment to support the kingdom and the world. It is a commitment that we are taking personally as an institution. We have decided to take tangible actions on a promise made to our children and grandchildren that we will spare them from an uncertain future brought about by the multifaceted impacts of our changing climate system. It is personal because we are putting the knowledge and technology that we have generated here at KAUST to the test. Can we offer tangible and acceptable solutions to the 4 R's of reduce, reuse, recycle, and remove? It is also personal because KAUST was created precisely for this reason, to generate knowledge and translate it for human benefit. Although we are launching the Circular Carbon initiatives today, KAUST has had a long record in formulating the intellectual and scientific underpinning for this circular carbon economy strategy. It is therefore not a coincidence that our Vice President Bradley, Professor Gascon, Professors Duarte, McCabe, Dowdy, Roberts, and Sarati, many of them are here, as well as our G20 and S20 Secretariat, have been busy for over a year now in contributing to 2 key G20 working groups that help deliver the circular carbon economy agenda to the G20. So this group, the first one is the Climate Stewardship Working Group, and the second one is the Energy Sustainability Working Group. The adoption of the Circular Carbon Economy platform in the G20 Leaders' Declaration was the result of the strong leadership of His Royal Highness, we just heard, and the heroic effort of many contributors, including those from KAUST. Indeed, to be frank, we all quietly celebrated here at KAUST upon hearing and reading the Leaders' Declarations. We read it immediately after they came out. Today, we take the extra step of showing leadership in research and translation under the theme of circular carbon economy by launching the Circular Carbon Initiative at KAUST. Given that the real problem is our changing climate, the goal of the Circular Carbon Economy platform must be to employ technology, natural solutions, and actions that are climate positive. Reversing the unabated increase of carbon dioxide in the atmosphere is not just about excluding hydrocarbons and fossil fuels in our energy future or near future. The focus should be on mitigating an impending global climate catastrophe. And we must do this by employing the best solution, be it policy, technology, or other action to reduce carbon dioxide levels. In other words, we need to be inclusive in our approach to reducing carbon dioxide emissions. Inclusive means employing all promising technologies behind the 4 R's. In practice, this is accomplished by promoting renewables, improving fuel efficiency, reducing emissions, capturing carbon dioxide, and either utilizing them or sequestering them in natural carbon sinks and geological storage. In addition to individual faculty research, KAUST has also deployed our KAUST research centers, which by design are not only goal-oriented, but are likewise driven by translation capabilities from proof of concept, upscaling technologies, as well as piloting deployment. Later today, for example, we'll be signing an agreement with NEOM, and there's several representatives from NEOM here, that will enable deployment and upscaling of important circular carbon technologies. The KAUST Research Center that have been involved in various facets of the circular carbon economy include quite a number. The KAUST Catalysis Center, the Clean Combustion Research Center, KAUST Solar Center, Advanced Membrane and Porous Materials Center, Petroleum Engineering Research Center. In these centers such as the Red Sea Research Center, Water Desalination and Reuse Center, and the Center for Desert Agriculture are also involved. So of the total of about a dozen of our research centers, you can count 2/3 of our research centers are involved in this initiative. The circular carbon economy research theme is also patently transdisciplinary. So I encourage KAUST faculty from all of our 3 divisions to get involved in the circular carbon initiative. It is equally important to get a sense of missing expertise or infrastructure, if any. so we can identify additional national and global partners with complementary expertise. Indeed, one of the examples, and you'll hear later, is Dr. Bill McDonald, who is now signed on to as an distinguished adjunct professor at KAUST. He will be giving a speech later on this program, and he here at KAUST precisely for this reason, because we don't have this kind of expertise yet. Now, the time is right for KAUST to mobilize its world-class expertise in the field of circular carbon economy, especially at this time when there's a strong global push for a green recovery approach to our post-COVID world. At the KAUST CCI exhibits next door and also in the next hall, I hope you all get to appreciate the diverse, foresightful, and innovative ideas of our research community. I urge all of you to be part of this initiative one way or another. We need all hands on deck in finding solutions to what could be the defining challenge of our generation. Thank you very much.
It's my great pleasure to ask Professor Gaston to present his presentation.
So thank you very much, Donald. Sorry, it took me a little bit to get here. So, Your Royal Highnesses, Your Excellences, distinguished guests, KAUST colleagues, ladies and gentlemen, it is an honor and a privilege to be here before you today as we celebrate the launch of the KAUST Circular Carbon Initiative. In the next 15 minutes, I will give you a flavor of the work that we are doing at KAUST to contribute to a more sustainable future and to support the Kingdom of Saudi Arabia in its leadership role in the arena of the circular carbon economy. At KAUST, we believe that the present defines the future and that the future builds on the foundation of the past. When it comes to circular carbon technologies, ladies and gentlemen, we can confidently say that KAUST is building on the strongest foundation. Indeed, as already mentioned before by our President and Vice President for Research, I can assure you that circular carbon is imprinted in the DNA of KAUST, of this university, since the day it was incepted. In the slide here, you can see a beautiful scheme that summarizes the principle, and let me also say the beauty of the circular carbon economy. I will, however, not go into too much detail, as we will have the pleasure to have it explained by its creator, Professor Bill McDonald, during his plenary lecture later today. So please allow me to go directly to our main objectives, the way we have decided to organize our initiative, and more importantly, into the exciting work that we are doing. First of all, let me highlight what is the main objective of our initiative. The main objective of our initiative is to speed up the translation and the application of technologies related to the circular carbon economy. In doing so, we are sure that we are going to contribute strongly to the national program on the circular carbon economy, and the way we are going to do that is by comparing technologies from a completely technology-agnostic manner. The way you do that is by exactly doing impact assessment of these circular carbon economy technologies and identification of potential bottlenecks, environmental analysis, and techno-economical assessment. Now, the way we have divided this initiative goes along the 4 R's of the Circular Carbon Initiative, and we are harvesting here on the expertise present at KAUST in such a way that we have defined different research thrusts, going from CO2 capture to nature-based solutions, geological solutions, e-fuels, and finally a cross-disciplinary thrust that works on how we can implement renewable energy on the smartest way possible. Now, over the next slides, I will go from CO2 capture clockwise through all these thrusts and highlight a couple of examples of the research that we are doing. Let me start by CO2 capture, and let me start by talking about CO2 capture. I am sure that most of you are aware that the more diluted CO2 is, the more complex and the more expensive it is to capture it. Right? So here you have an example in the graph here of prices at this moment of capturing carbon dioxide from different sources. Now in the bottom, you can see a very nice material. That's a metal organic framework called KAUST 7. And let me now come back to the history of KAUST with CCE technologies. This material is called KAUST 7 because it was patented on the 7th anniversary of this university. I think that with this, we are giving testament that we are not newcomers to the field of circular carbon economy. KAUST 7 is an excellent material for the capture of carbon dioxide. Indeed, I don't know of any competitor that is able to capture carbon dioxide from diluted streams in the presence of steam and in the presence of oxygen that does as well as this material. What we are doing now is, after this initial phase of discovery, we are partnering with two industrial partners, Saudi Aramco and Svente, to demonstrate this technology at the 1 ton of CO2 per day scale in CO2 capture from very diluted streams, in this case, a 4% of CO2. Now, also during my introductory slide, I mentioned that we are getting into this from a completely technology agnostic manner. There are other ways of capturing CO2. A completely different way, which is based on a thermodynamic cycle, is cryogenic CO2 capture. This is a technology in which we also believe, and we are doing our best efforts to bring that technology to the kingdom. In this case, again, partnering with another industrial partner, in this case, Sustainable Energy Solutions, we are bringing cryogenic CO2 capture to the kingdom. We have actually already brought it. What you can see there on this slide are 3 containers that contain the pilot scale plant able already to capture 1 ton of carbon dioxide per day. This plant is at this moment being tested here inside of KAUST, and it will be moved at the beginning of next year to Rabik, to an HFO energy generation plant to be tested under real conditions. With this, we will not only learn much more about this technology and we'll learn how to make it operate cheaper, but we will also put it to its grounds and check if some of the current technologies that are being applied at this moment as a post-treatment of these flue gases can actually be eliminated by applying this new technology. This is, by the way, the technology that MOU was signed yesterday with NEOM. We are striving to bring this technology also to NEOM for the capture of CO2 there and the manufacture of e-fuels out of the captured carbon dioxide. We move now to nature-based solutions, and with nature-based solutions, we are putting a special emphasis in helping decision makers take informed decisions based on the best scientific evidence. A very clear example is that in many cases, when it comes to nature-based solutions, one has to consider that, for instance, capturing CO2 may come at a price in terms of water usage, for instance. There is a clear nexus there. We want to make sure that those who are to take the decisions on which nature-based solutions to invest have the best scientific evidence to go for the best solutions. Next to that, we are helping decision makers by making the first atlas, in this case together with Geomar in Germany, of nature-based solutions, the first geographical atlas. Here you have an example, for instance, focusing on different nature-based solutions on coastal applications in such a way that this atlas is going to be available to all decision makers, and when it comes to making investments in nature-based solutions, they will know in their geographical location what is the best location, the most impactful location to start investing on nature-based solutions. But we are not stopping there when it comes to nature-based solutions. We are especially focusing in the kingdom. We are looking at opportunities for CO2 capture from the oceans all the way to the deserts. And here we are looking at afforestation restoration, and we are applying there state-of-the-art sensing technology and artificial intelligence to understand better what is the effect of afforestation and reforestation. We are looking at CO2 capture by microbes and by oceanic forest. And finally, we are looking at large marine animals as very important sinks for carbon dioxide capture. And we are quantifying the effect of each one of these nature-based solutions. Extremely important for the kingdom is also going to be geo-based solutions. And with this initiative, we really want to push forward geo-based solutions when it comes to both green energy generation and CO2 capture capabilities. Things that we are doing go from studying what are the best aquifers in the kingdom to capture carbon dioxide, all the way to geochemistry in the mineralization of carbon dioxide to make basaltic rocks. We are collaborating with our partners in Aramco to make enhanced oil recovery more efficient, and we are developing numerical methods to better simulate CO2 reservoirs and to use geo-based solutions for energy storage. Last but not least, we are looking at the generation of green energy from geothermal energy, and here we are looking at the best locations in the kingdom to generate geothermal energy and at models of ways in which this geothermal energy can be used from housing all the way to industrial installations. Now, once you have captured CO2, you can either store it or you can do your best to bring it back to the production chain, right? The e-fuels part, a large part of this thrust, focuses on recycling this carbon dioxide in the form of CO2 neutral fuels. First thing that we are doing here is to apply artificial intelligence to decide what is the best fuel composition to be applied. Once we do that, we go to transformation methods based on catalytic routes in which we can directly transform carbon dioxide and water to different products, be it formic acid, be it methanol, be it drop-in fuels, be it syngas to make materials out of this carbon dioxide. And we are going several steps forward. We also want to help decision makers here by assessing the whole process and giving guidelines as to when the production of these products from carbon dioxide is going to be profitable. Should there be a CO2 tax to make CO2-based technologies profitable? These are all type of studies that we are doing within this initiative. Last but not least, in the e-fuels, we are also pushing, especially together with our partners in Aramco, for the green and blue ammonia economy, energy economy. For those of you who are familiar with ammonia, ammonia is an excellent medium of transport hydrogen because ammonia is a liquid product. And technology to make ammonia out of hydrogen and nitrogen has been known already for centuries. Now, you may have two strategies here. One is using renewable energy to generate green hydrogen and put this green hydrogen in the form of green ammonia, or one can use hydrocarbons, the hydrocarbons reserves in the kingdom, to generate hydrogen, capture directly that CO2 before the hydrocarbon is sold out, and then make blue ammonia out of that blue hydrogen generated from hydrocarbons. I think that you all read in the newspapers some of the first shipments from blue ammonia from the kingdom to Japan. This is the type of technology that I am talking about. Now here the main issue is on the left of the slide, which is on the utilization of this ammonia. You have here two options. Option number one will be to use ammonia directly in a combustion engine to produce energy. This is something that we are doing together with Aramco already at the 350 kilowatts scale. Another option is to transform back this ammonia into hydrogen and nitrogen and use that hydrogen. This is something that we are also doing with Aramco, and we are at this moment building a demonstrator at the 5 cubic meters per hour scale that will be ready before the end of next year. Last but not least, we need to improve the use of renewable energy. It's not only about implementing as fast as possible, it's about making the best out of the renewable energy that we implement, right? That means that we are working specifically for the kingdom on two different topics here. The first one is to try to improve the current photovoltaics technologies for the very harsh conditions that we have in the kingdom in terms of temperature and in terms of dust. But we are not stopping there. We are also making the solar photovoltaics of the future based on new materials, and at this moment KAUST holds the world record in terms of efficiency, which is what you have there in the bottom. Finally, once you go to a much more complex energy mix as the one that we have now, it is extremely important to decide how to maximize the use of green energy and how to minimize the use of energy. For that, we are combining artificial intelligence and the Internet of Things to prioritize use of different sources of energy at given moments of the day. This is the so-called digital twin technologies that we are at this moment applying to the city scale, but we don't want to stop there. We want to make digital twins of chemical plants, of refineries, so that at every single moment the use of energy is optimized, and we know that we can get energy savings in the order of a 30%. With this, I get to the end of my to the last slide of my presentations, but I would not like to finish without inviting you to the exhibition, where we will be able to share with you our vision of a sustainable future. Last but not least, if you are to leave this room with only one take-home message, let it be the next one. In this earth shot that we are all together, and it will be together how we will succeed. Let's remind ourselves, as we no longer see the obstacles behind us, but look forward to the ones ahead, that in this earth shot there are no passengers because we are all crew. Thank you very much.
Thank you. So we're hoping to now move over to the presentation from Professor Bill McDonough. So Bill is in Virginia in the US, so it's early morning for him.
Hello, I'm William McDonough. Today I'm going to talk about the circular carbon economy. But first, I would like to congratulate the Kingdom of Saudi Arabia on its presidency of the G20, because it was very successful with regard to the idea of all the countries coming together to solve our common problems and needs, and share technology and share our ambitions and goodwill. I'd like to thank His Royal Highness Prince Abdulaziz bin Salman. I'd like to thank Khalid Abouliaf and Farid Al-Sali and Taha Zatari from the Ministry of Energy. And I'd like to thank Adam Szyminski and Eric Williams of CAPSARC for all the great work they allowed me to participate in. So let us see what is coming out of the G20 and imagine what that means to all of us. Look at this. As we recover from the pandemic, an opportunity for all the people on the planet to come together. We are committed to safeguarding our planet and building a more environmentally sustainable, inclusive future for all people. This is not a hollow statement. It's a statement waiting to be filled in. We endorse the Circular Carbon Economy Platform with its 4 R's framework: reduce, reuse, recycle, and remove. The addition of the word remove is fundamental. And it's a voluntary program looking at all sectors, and it will be something the world can celebrate and enjoy. Now, I have recently become a faculty member at KAUST. I'm very excited about that. And I'm very excited about the fact that I'll be able to work with professors and students there as we advance this cause. My history goes back to design. I'm an architect. And I wrote a book with Michael Braungart, a German chemist, Cradle to Cradle, which is considered a seminal document in the history of sustainable design. It led us to circular economy, and then now the circular carbon economy. These things all fit together. The world in which they fit together is the world we inhabit. A world where energy comes from the sun, carbon comes from the atmosphere, materials are here, and water. They all combine to create biology and life, which is where we fit in this story. Humans are part of biology. We come as a word from the word humus. So this system is the system in which we're working. We realize that if we're being very efficient today about doing things, but it turns out we might not be doing the right things for that diagram, then we have a problem. And if we do it perfectly, we become perfectly wrong. So I think what we're seeing with this G20 announcement is effectiveness. It's executives coming together to figure out what are the right things to do. Then we'll put it into the management situation and try and manage it and do it the right way. Now, as a designer, when I was 19 in college, I decided I wanted to look at how to design buildings like trees. Why not? Trees emit oxygen, so they're not zero emissions. They're positive emissions. They sequester carbon. They fix nitrogen. They accrue solar energy. They create food, fuel, water, habitat, microclimate. They can change colors. They can even self-replicate. So why don't we have human designs that can do things like this? And when you start to look at some of the ambitions we're seeing, like the city of Neom and the Red Sea Development Project in Saudi Arabia and others, we realize this is what we're talking about. Positive actions. In '89, I designed a skyscraper that won a competition, and I asked the developers to plant 10 square miles of trees to go with it. This you could call carbon offsets. And this is 3 years before the Earth Summit. But notice that at that time, it was $150,000 to plant 10 square miles of trees in Poland. It's 1/10 of the advertising budget. But what this is an offset. It's saying, here's a building made primarily from energy from coal, and we're going to try and offset it with trees that could take care of the carbon involved in operating and building a building. It's offsets because you can't do it on the building itself, for example. But we realize that's adding renewables to the mix, or adding carbon capture to the mix from nature-based systems. But we can also make buildings that actually produce more electricity than they require from renewable sources. And this we could call an energy positive building. This is the first net zero energy verified building in the United States. And it's energy positive. It produces 30% more energy, electricity than it requires to operate, and gives it to the neighbors while purifying its own water. At Ford Motor Company, I was asked to work on their 100th anniversary new factory at the River Rouge, the famous fabled facility of Henry Ford, vertically integrated industrial process to make the Model A Ford. And this factory is covered with the world's largest green roof, and its site does all the water purification, which eliminated the need for 3 chemical treatment plants and miles of concrete pipes, and saved Ford $35 million over conventional water treatment on the site, which is the equivalent of the profit of 4% margin on $900 million worth of car sales. So this is business. This is important business. While we save the planet, we can do business. NASA asked me to help on the Mars space station by design, and I asked if I could work with the designers at NASA to do a building on Earth, come back to the blue planet before we go to the red one. And we were able to design a building at NASA Ames Research Center on time, on budget, a normal federal office building that has potential to produce 140% of the energy it requires from renewable sources. The materials are designed to go back into industry, aluminum to aluminum, glass to glass, and it shades itself and is now considered the highest performing building in the federal government. They say you don't need to be a rocket scientist to do something smart, but what if you were? So once I was designing buildings like this, I realized that we have to think at every scale. It comes down to the products. It comes down to the molecules. It's urban design. It's a whole world of good. So it's really about every scale. And that's why I love working with scientists. With Cradle to Cradle, we posited that there are 2 metabolisms that we're working with. One is the biological system. These are products of consumption. They can be consumed and then go back to nature. Waste equals food. At the same time, in the last 5,000 years, we started banging on metal and things like that, not organic materials. And these can go into products that we want. These are things we want to use. And these are materials in technical cycles, products as services. We want to watch television, watch this show on a computer, get vehicles that take us places. But we don't need to own all the chemistry. What we want to do is take advantage of the service. So there's new business models for this. Very exciting. The fundamental principles of Cradle to Cradle were waste equals food, eliminate the concept of waste, not just minimize, avoid, reduce, use clean energy, and celebrate diversity. This is how nature works. And all of these things are wonderful things for nature and for industry. So we move from a linear economy of take, make, waste to a circular economy, retake, remake, regenerate, restore. We need a regenerative economy in the biosphere and a circular economy in the technosphere. So in 1995, I designed my first product elevator building, and it was fabrics made in Switzerland, where we removed things. We removed persistent toxins, bioaccumulative substances, endocrine disruptors, teratogens, carcinogens, mutagens, heavy metals from the making of a fabric. And it turned out to be so safe you could almost eat it, and the water coming out was as clean as Swiss drinking water. This is living carbon, and it supports life. It is the preferred material of the Airbus. We also looked at the technical nutrient idea, the products, these are polymers, and this is the world's largest carpet company that we work with, and they make a product as a service in a sense. You buy the carpet and you can call them when you want a new one, and they take the other one back and recycle it for you using chemical recycling or mechanical, and they deliver the new carpet. So what's happening is the companies are storing the raw materials on their customers' floors. It's a relationship, it's valuable, and it's something we can do in perpetuity. This is the circular economy. At Herman Miller, I designed their factory, and then we decided to do the furniture this way. The Mira chair was the first Cradle to Cradle certified chair. Now we have all their furniture. This is powered by wind and designed for disassembly and reuse of all the pieces. So that turned into a program that I created with my colleagues, and we produced a not-for-profit that is a certification program, third-party, independent, science-based, available to everyone now. And it's just been selected by Amazon as a preferred certification program for Amazon for their products. Now, what is Cradle to Cradle design? Well, it's material health, circular economy, renewable energy, water stewardship, and social fairness. So first is material health. Second is reuse, because why would I want a circular economy of things that aren't safe? So first is safe. Then we reuse it and turn these things into continuous assets. We want to use clean energy and restore carbon balances. We want water to be clean and available to all the children in the world as a human right. And we want social fairness. So we have dignity and grace. These are fundamental to all 17 of the Sustainable Development Goals. So we find it very useful with the companies and countries we work with that if you take these 5 conditions and make it a prerequisite for whatever you're making, you end up having a support system that can support all 17 Sustainable Development Goals. So it's very helpful. The history of circular economy, according to ABN AMRO, bank in the Netherlands, was looking at searches, was, from that, for them, starting with the Cradle to Cradle, going into China as the design of the circular economy with their universities, where I worked. And then China announced its 5-year plan, 12th 5-year plan, promotion of the circular economy in 2011. We introduced it to the World Economic Forum in 2014, the Ellen MacArthur Foundation, important report, 15, 16, China announced their 13th 5-year plan, implementation of the circular economy. This is a picture of me with Madame Deng Nan, Deng Xiaoping's daughter, And we were sharing in Beijing a paper that was entitled Cradle to Cradle, the Circular Economy and the Search for Ecological Civilization. This is China and the US sharing information about sustainable development. This sharing is so important in working together. And certainly in today's world, it's even more important, as we can see by the G20 and this astonishing result. The design of the circular economy got manifested in China and it's continuing. And we started looking even at cities as carbon positive cities, cities like forests that accrue carbon with technical materials returning to industry and all the systems integrated for positive effect. This is a concept piece for the China Development Bank. It's a city of 100,000 people that could be fed, powered, and with clean water, all from the surrounding territory, 128 square kilometers. And so when you see cities like Neom coming in Saudi Arabia, the same idea, a renewably powered city. What astonishing, wonderful things here 15 years later, coming to fruition. So at the World Economic Forum, I chaired the first Meta Council on the circular economy. And the World Economic Forum has put very serious thoughts and efforts into these programs, including into carbon now. Very exciting. And when we look at the development of this, starting with Cradle to Cradle, from my personal perspective, we move then to the point where on the lower left, Ellen MacArthur Foundation has adopted our protocols of biological technical cycles. But we also see people still drawing circles, saying that the linear economy becomes a circular economy if you put it in a circle. And I think that's not rich enough. I think the idea that we want to support technology and biology is really important. So if design is the first signal of human intention, then what is our intention? Did we intend to damage the soil, the air, and the water every year? Is that the plan? Was climate change a plan? It's actually the result of a design problem, the way we do things. So we need a new design. This is the stack: cradle to cradle, circular economy, circular carbon economy. We do these three things and we end up with a situation where we realize that carbon is not the enemy. As we see, so many people who are worried about carbon say we have to have a war on carbon, things like that. But carbon is not the enemy. It's an innocent element. And it's in our bodies, it's us. And let's tell our children carbon is a beautiful thing. We immediately assume things when we see, unless we see a little more deeply. This picture is often seen as being pollution. This is from Nature, the picture along with my article. That is fog. That is Vancouver. That meadow down there is a green roof on a convention center. That's a picture of something to want more of, not less. We surprise ourselves. We are carbon. So we use carbon as a tool for human purposes. And what are our values? And what are our intentions? Because if you give a hammer to a child, it becomes a toy. You give it to a carpenter, it becomes a house. And if you give it to a maniac, it could become a weapon. So what we really want is to recognize carbon as an amazing material and special in the circular economy and deserves special attention. So carbon is both a material and a fuel. So we need a new language of carbon. In the Nature paper I published in 2016, Carbon is Not the Enemy, we looked at carbon could be living carbon, which would be positive behavior if we could generate more of it. Durable carbon, which is lasting and recycled polymers and the use of wood beams in a building over centuries, so durable. That's carbon neutral behavior. And then there's this negative behavior, which is letting it go fugitive, the wrong place, wrong dose, wrong duration. And so we now have a way of thinking about it in terms of yes, yes, no. And so as we start designing, let's design with living carbon, durable carbon, and fugitive carbon. And one of the things that I really liked about the way it was being approached with the circular carbon economy strategy is that we have the basics of reduce, reuse, recycle. which is efficiency in the circular economy of materials typically, but we're also focusing in not just on reducing energy use and being more efficient on production, but we're actually saying we have to remove carbon from the atmosphere now. So it's unlike the circular economy, which doesn't necessarily have removal in it. It's really reuse. So I was very honored to be able to provide an appendix to the CC guide, which focused on energy and emissions and things like that, critical to our forward motion, but also integrating it into this idea of the circular economy. So if we look at the cradle-to-cradle circular economy of biosphere and technosphere, they're both accelerated by energy use and require it. So if we start to think about how carbon interacts with these cycles in nature, in the biosphere, nature can be balanced because the nature knows how to do that. But in the technosphere, it doesn't necessarily know how to do that. We use, petroleum or fossil fuels, and then we have emissions, and they go to the atmosphere principally. Whereas if we can start to think about the technosphere having a circularity of carbon, it gets very interesting. And I think this is the kind of diagram we should start to use as a touch point for all kinds of things that we can explore. I'm developing this with Carlos Duarte, who's at KAUST, and with the Energy Ministry, and with CAPSARC, and we're looking at the biosphere and the technosphere. So the biosphere is regenerative, and we can call it the regenerative biosphere with living carbon, and we are recarbonizing the biosphere. When we talk about decarbonizing, we're talking about the atmosphere, not just generally. You don't want to decarbonize yourself, you wouldn't be here. So decarbonizing is the atmosphere. And so we can all come together now and start to look at what our goals are. And we can put whatever our goal is there. And for the Europeans, it's net zero by 2050. For Chinese, net zero by 2060. For companies like Unilever, net zero by 2039, believe it or not. So these are goals, and everybody can put that goal there, and then we can all ask ourselves, no longer what's wrong with your goal or the way you're doing it, but how can we help you? And when you start to look at this diagram, you can say, oh, I could help you with this. We're going to want to make a lot of hydrogen in the kingdom, a lot. And NEOM's committing to it. Well, we're going to need a lot of electrolyzers and new technologies for hydrogen production. So that's exciting. So industrial countries can do this. We can produce hydrogen with our inexpensive renewable power. And all of a sudden we can be trading. That's already started. It's very beautiful. And it's just the beginning, but this can all go to scale. We can look at nature-based solutions and see how much we can do with that. And it's just gonna be good for everyone, because mangroves and restoration of large mammals and regenerative farming are all phenomenally useful and beneficial in every direction. So optimization is the order of the day, not just minimize, reduce, avoid. It's actually optimize now. So we can use this diagram as a starting point, and others. It's very exciting. And it does help us to think like that, because if we're looking, for example, at petrochemicals, then we can ask ourselves, hydrocarbons can be used as durable carbon and reduce the energy demand of our buildings. So it's a very wonderful use of these materials. We can do things like this, which is a window insert that can be used in northern climates, especially to reduce energy consumption in historic buildings, because it goes on the inside. It's very light, you can't even see it almost. So these are the kind of products we're going to need if we're going to have zero emission cities in places with intense climate. We're also looking at things that are reusable. This is a whole system of packaging that I'm working with some colleagues on that is all able to give you sort of a lifetime of benefit with your packaging while you connect. This can all be connected with polymers that are reused and materials of all kinds. Just remember, I think the aluminum industry says that 75% of the aluminum ever used by humans is still in use. So if we look at these ideas of new kinds of trading where we're buying back things, or a carbon fountain where we're using carbon neutral fuels by taking CO2 from the atmosphere and then integrating it with hydrogen from renewables and then send it back up. What this is showing is that we're not just being less bad, we're trying to be good. Because being less bad is not that exciting, really. It's important we do it, but this design assignment is much more interesting if our goal is not just zero badness, but actually what does 100% great look like? And we can all commit to do this together and start to see positive goals where we take all the things we don't want and agree, let's stop doing those things. And let's find out what we do want and put it on top. And then our goal becomes positive goal, 100% fabulous. And so together, this is something we can do, and we can only do it together. And that was the message from the G20. Thank you.
Welcome, Bill. We're very pleased to have you with us again today. So this is Donald Bradley. I know you can't see us, so just to let you know. So we have an opportunity to ask some questions. If anybody would like to ask a question for Bill.
Thank you. David McKenna here from Amala. I'm Director of Sustainability at Amala. I just have one question in relation to terminology around carbon neutral, carbon balance, net zero. From your perspective over in the US and other places where you've visited, which is the preferred terminology that's internationally accepted in relation to net zero and carbon neutral? Do you feel that the circular carbon economy terminology is being accepted and will be ratified fully under the UNFCCC and accepted internationally?
I think that's one of the big questions today. I can't really answer that question. I have talked with them. And I think that one of the things we need to sort through is this definitional question. I think in Europe, certainly net zero is catching hold. And the question then becomes the question of the offset. I think this is going to be the fundamental sticking point for a lot of people, I noticed. That when you think of net zero and you're trying to do statistical significance, you then have to consider the offset for most people. So if you see companies and I work with a lot of companies and CEOs, and they want to be carbon neutral. They talk about that. And they talk about net zero because they hear a lot of people saying you should be net zero. So you'll hear all these terms, low carbon, net zero, so on and so forth. But I think one of the key things here is to really focus on this question of decarbonizing the atmosphere and recarbonizing the biosphere. I think that's a fundamental thing. I had a meeting yesterday with a big group in London, virtually, about the use of these terms, and it was really helpful to look at it that way. And the reason is that there's a strange fallacy in a strange way. There's a fallacy of the offset. Because if I say I'll do energy reduction everywhere, as much as they can, and that's always a good idea. It's economical as well. But to reduce my emissions if the energy is coming from emitting energy, and renewables and all those things. But at a certain point, I'm not carbon balanced because I can't actually be taking carbon from the atmosphere unless I do offsets and I apply it to nature-based solutions, for example. But in some cases, a nature-based solution for some places is to say, draw a line around this piece of forest, and then I'll take credit for that carbon capture. But actually, that forest has been carbon active for a long time. And so you haven't added to the world of carbon sequestration in soil. So you've just called that out as your catalog. So if you also say, I've increased my renewables and to X, and that offsets the same amount in energy that would have producing carbon, and I'm offset, so I'm net zero, well, then you realize that's really not scientific because the renewables don't produce carbon, for example. So they're not the same. So if that would logically then mean you could double your renewables and double your emissions, and you're still zero emissions offset. But you're not, you just double the carbon emissions. So we have to become very precise. So I think the big issue is going to become this issue of removal, actually. And the idea that KAUST is looking at how to drive down Aramco and so on, drive the cost of mechanical removal using science, using renewable power to do it, obviously, is really a key element in that discussion because it will help us become able to create rational statements that are accurate and not just relational, but actually statistically coherent. And we have to really move on this. And I think it's great that we're going to be looking at everything at once because if we look at nature-based solutions and what their capacity for removal will be, I think we're going to find that we need a lot of help from the technical side. And the technosphere has to get engaged in this question. And I think that's part of the order of the day. So I think you will hear net zero a lot. And I don't know if it'll end up being in the UN and being that specific, because then we have to decide what does net mean? And we get into that same discussion again. So I think focusing really seriously on removal is a very important idea right now.
Thank you, Bill. We have another question here. So.
Yes, thank you for your explanation, Mr. McDonough. I am Dina Al-Nahdi from board member, Jeddah Chamber of Commerce. I've been discussing about circular economy for the past 6 years with different government entities and promoting the implementation of it. Now, I'd like to know, how do you see that we could start implementing different aspects of the circular economy? Because yes, we cannot do it all at once, but implementing different parts of it in different aspects, say in the industrial cities, separately from the farms and farming or poultry industry and so on. We'd like to see it more vast and more, happening in all different kinds of sectors, starting from smaller up into the large scale. And yes, we are very proud of NEOM and Gidea and Amala and others, but we wish to see this being implemented throughout the kingdom on all levels, and maybe starting by even chipping it down into the industrial cities and factories individually. So how do you see this happening? How can we promote this and help this PPP happen? And of course, through the technologies and researches with KAUST as well. Thank you.
It's such a wonderful question because it shows the influence of these projects that are looking at the future and reinforces the need for these ideas to be translated across into the present everywhere. So thank you for that. What we find is that I find the power of the purchase order. If you think about all the discussions we have about policies and setting forth policy, those things are obviously important because they're an expression of society's interest. But there's nothing more powerful than commerce in this as an engine of change. So, for example, if Jeddah said, we are developing a protocol where we will prefer products that are this way, for example. And so we have San Francisco prefers cradle-to-cradle certified products as a city. So when you go to put a carpet in an office building in San Francisco, they will say, we want cost, we want performance, we want aesthetics. Those are all the things that people normally deliver in a product, but we also want it to be ecologically intelligent and designed for circularity with take-back systems or with optimizations in the circular economy. So that's why we created the certification program. So that's the kind of thing you can do. You can just say, we prefer things this way. And then our purchase orders or our incentives that we set up will be directed toward preferring these things, as long as they meet all the other criteria that are required. That's really the only way I think that it's ultimately going to happen, is by action. And I find the power of commerce to be probably most effective.
Thank you, Bill. One last question.
My name is Matar Al-Dhafiri. I am the Vice President of SIBChem. SIBChem is a petrochemical company. It's a listed company. I just want to hear your perspective about the petrochemical. Are we considered a culprit? Are we a source of fugitive CO2? Or we are, fugitive carbon, or we are a source of durable carbon? Because eventually, if there is no petrochemicals, most of the hydrocarbons that will be emitted from the oil and gas will be either used for fuels or burned out. So where do you place the petrochemical industry in the space of circular carbon?
I think that on the diagram, if we look at that, this is where we're looking at the technical nutrition issue. So I think that the polymers and durable carbon made from hydrocarbons are going to be a fundamental part of any future, clearly. And the question is how much of the carbon is needed for that. And as we look at carbon capture, for example, and we say CO2 capture and then hydrogen production, and we can go back to ethanol and so on, and then use it in process and equipment or products, as well as synthetic fuels and things like that. What's the dimension of all these things? So I think the issue of getting durable carbon from petrochemicals is fundamental to the rest of human existence. So the question is, how much do we need? How are we producing it? How can we make it into the circular carbon cycles? And so I think the other question would be, where do we shift our energy flux to the things like hydrogen as they come in, so that we can go for non-carbon emitting energy sources, as well as optimization of the carbon energy, where emissions can be captured, like we're seeing with the blue hydrogen and so on. So I think that it's really the optimization scenario, but there's always going to be a need for polymerization and the materials, the benefit for humanity of these kinds of materials. And chemical recycling, I think, will surprise everyone at its efficacy over the next decades as a critical equation within the polymer industry, because we're going to have materials that can go back to soil in the biosphere. Right now, I'm working on 2 major packaging protocols for how to do packaging that can return to soil and safe in the oceans, things like that. A lot of people are concerned about it. And we can actually use petrochemicals to make these things. So that's a really interesting area to study, which is when do hydrocarbons become able to become carbohydrates? That's very interesting to me. Because in the future of agriculture, we're going to need agricultural mulch films. And if we want to do all this restoration of soils and so on, polymers can play an amazingly important part in the restoration of soil ecologies. And they could actually be hydrocarbons that are designed to go back to carbohydrate. It's oil to soil in a wonderful image. But there's also the need for all these other polymers that can be mechanically recycled, like PET, or chemically recycled, like most of it. And so I really think we can get that system optimized and then just go after the carbon emissions very specifically and very grandly. And as Carlos Duarte pointed out yesterday, I really do see, the whole idea of the Saudi Arabia of hydrogen coming, for example. But that hydrogen is there to play an important role in large-scale thermal needs for industrial heat in countries all over. And the fact that we could ship renewable power from the Red Sea to Japan, amazing. This is the first time in history that we're seeing one place that has immensely inexpensive renewable energy being able to ship it halfway around the world. What an incredible thing. We're sharing renewable power. Because hydrogen is not a source of energy, it's a carrier. And hydrogen will enhance the petrochemical industry because it provides the hydrogen we need when we have the carbon. So it's all coming together now. And I think the key thing is for us all to feather out all the pieces of this so we can come back and speak about every element with dignity and grace.
Thank you, Bill. I think we have run out of time, so please join me in thanking Bill for his presentation and questions. Thank you. So I would now like to call on Ms. Nufi Mann from the British Consulate in Jeddah to introduce the Science Innovation UK Earthshot Prize.
Your Royal Highnesses, Your Excellencies, and distinguished guests, Assalamu alaikum and good afternoon. My name is Nof Imam. I'm from the UK Science and Innovation Network based in the British Consulate General in Jeddah. I'm very delighted to be here with you as we celebrate the launch of KAUST Circular Carbon Initiative. Today, I will speak to you about an exciting opportunity for those with ambition to repair the planet we live in. So, it's an international award that is designed to harness the brightest ideas for tackling the biggest environmental challenges in the world, the Earthshot Prize. This is a new global prize. It is the most prestigious and ambitious of its kind. The overarching objective of the prize is to incentivize change and help repair the planet over the next 10 years. The initiative is spearheaded by His Royal Highness Prince William, the Duke of Cambridge, and in his own words, the Earth is at a tipping point and we face a stark choice. Either we continue as we are and irreparably damage our planet, or we remember our unique power as human beings and our continual ability to lead, innovate, and problem solve. People can achieve great things. The next 10 years present us with one of our greatest tests, a decade of action to repair the planet. So why the next 10 years? This decade ahead will determine whether we stand any chance of preventing irreversible damage to our environment. The world faces pressing environmental challenges and threats to life on Earth that require immediate action. The urgency of the situation is no longer debatable. However, despite these serious threats and all the alarming and terrifying headlines we see in the news all the time, we can't just lose all hope. No matter how complex, how huge the problems seem to be, we need to believe that by being optimistic, confident, and by working together, things can take a positive turn. Inspired by the moonshot that Kennedy proposed in the 1960s, the Earthshots aim to refocus existing efforts and challenge people to be more ambitious than ever and to inspire innovative ways of tackling today's challenges. The moonshot is a wonderful example, not only because it united people from all over the world around one goal that seemed impossible at the time, but also because it has generated a spiral of countless advances in technology, including MRI scanners for hospitals and satellite dishes. Similarly, we hope that this prize and this challenge will also have a snowball effect of triggering unexpected advances and solutions. So, applying the same spirit, in order to tackle the environmental challenges, we definitely must understand the urgency of this crucial decade, but equally have an optimistic view and mindset which will lead us to take decisive action. Okay, so that was some background on the motivation behind it and the inspiration behind this prize. But what is actually the Earthshot Prize? So these are basically 5 goals, 5 Earthshots we want to achieve by 2030 to improve life for us all for generations to come. What are these goals? It is to protect and restore nature. Just need to go back. Yeah. Protect and restore nature, clean our air, revive our ocean, build a waste-free world, and fix our climate. So every year, starting 2021 until 2030, Prince William, alongside the Earthshot Prize Council, which covers 6 continents, will award the Earthshot Prize to 5 winners, 1 per Earthshot, whose evidence-based solution make the most progress towards these goals. So 5 goals, 5 Earthshots, 5 prizes per year for the next 10 years. You can see here the criteria. Each Earthshot has to be simple, evidence-based, but can be understood by anyone and does not require technical expertise or scientific knowledge to be understood. It has to be ambitious, yet can be achieved and can lead to tangible progress. Last but not least, it must be global. Leaders, communities, and everyone should be able to connect to it and be empowered by it. So you can see here the selection process for the winners. For each, this process has been designed in partnership with the Center for Public Impact and a range of international experts. It starts by the nominators who will seek out solutions from across the globe that will help us reach our Earthshots. Then we move to screening, which is an independent assessment process run by Deloitte, the implementation partner. Then we go into shortlisting. A distinguished panel of experts will conduct a technical review and make recommendations accordingly. Then selection, which will be done by Prince William and the Earthshot Prize Council, will select the 5 winners. Finally, the award. The winners will receive £1 million prize to support agreed environmental projects. After the awards, each winner will also receive a global platform and a prestigious profile with their stories being showcased over the decade, with an ambition of their solutions leading to mass adaptation, replication, and scaling. Finalists will also be given tailored support and opportunities to help scale their work, including being connected with an ecosystem of like-minded individuals and organizations. So going back to the nominators who will start the process, the nominators have been selected for their ability to identify the most impactful solutions from all over the world. These are organizations that are committed to environmental action, who share the ambition of the prize as well. So it is no surprise that KAUST is one of the nominators, and the team here is actually involved and have already started the process to select solutions to nominate for the prize, and we're excited to know more about that as the process continues. Before I conclude, I would like to invite you all to follow the social channels for the Earthshot Prize Foundation and stay up to date with what's coming next, and hopefully the next award in London in 2021 will be exciting. I hope this has inspired us all to be more positive towards the future and think how we can work together to make the impossible possible again. Thank you so much.
Thank you very much, Ms. Iman. So we're now going to have the showing of our video.
The circular carbon economy is a sustainable way of approaching energy and climate goals. It implicitly values all options and encourages all efforts to mitigate carbon accumulation in the atmosphere while facilitating global economic growth. Inspired by nature, it is a closed-loop system where carbon emissions are reduced, reused, recycled, and removed to restore the balance of the carbon cycle. KAUST is catalyzing the circular carbon economy by contributing scientific advances in the development of engineering, chemical and biological technologies, in addition to clean and traditional energy solutions, which include hydrogen fuel and other advanced materials. The city of the future efficiently manages energy production and use. KAUST researchers are developing technologies by integrating next-generation solar cells with efficiencies greater than 28%, hydrogen production, smart decentralized wastewater treatment, novel air conditioning, and energy-saving lights for smarter homes and neighborhoods. Artificial intelligence technology further supports city-scale planning and operation, enabling reduced energy consumption and CO2 emissions. The future of farming is sustainable and smart. KAUST researchers are using flexible, lightweight, easy-to-install thin-film panels as solar screens and semi-transparent solar cell windows on greenhouses to both optimize plant growth conditions and generate electricity. Emerging sensors and remote sensing tools offer an improved capacity to track and monitor water use and account for the carbon generated. Self-cleaning solar panels are used in arid, dusty regions to ensure power supply. Fresh vegetables are grown using salt water via technology that reduces typical greenhouse cooling requirements and ensures efficient plant growth. Organic waste is recycled for desert agriculture, increasing food security while significantly reducing water consumption and pollution to fight desertification and climate change. Decarbonizing the atmosphere to recarbonize the biosphere. KAUST researchers are seeking to exploit nature-based solutions to reduce atmospheric CO2 levels while enriching terrestrial and ocean ecosystems, focusing on a blue carbon approach via mangrove and seagrass restoration projects, on recycling CO2 with bacterial systems, and on algae farming. These solutions target both climate change mitigation and adaptation. Redefining CO2 as a valuable material, KAUST researchers are reusing CO2 in combination with green hydrogen to produce e-fuels that can be used for sustainable mobility, the conversion of renewable energy to formic acid, and catalysts that can turn CO2 into useful platform chemicals for fuels, such as methanol and syngas, can provide a blueprint for the gas station of the future. Green and blue ammonia are also explored as carbon-free fuels. And together with McLaren, we're investigating e-fuel formulations for Formula One cars. Carbon capture and storage are essential to manage down the impacts of atmospheric CO2 levels. KAUST researchers are helping to reduce the CO2 reaching the atmosphere and looking to remove CO2 that is already accumulated there, Novel materials and processes address capture directly from the air and at point of emission sources. Storage via geo-based solutions, including basaltic rock chemistry. Use for enhanced oil recovery and for geothermal energy transport are also key. The Kingdom of Saudi Arabia has created its own National Circular Carbon Economy Program. KSA and 195 other parties have signed the Paris Agreement to lower CO2 emissions by reducing, reusing, removing, and recycling carbon. We at KAUST are doing our part to contribute to this at a national level by supporting the Kingdom of Saudi Arabia in championing their CCE program. KAUST's Circular Carbon Initiative aims to fill the innovation gap through multidisciplinary research and development. We welcome you to the KAUST Circular Carbon Initiative, and we invite you to join us in discussing and exploring ideas to further advance the Kingdom by improving the health of our planet.
Hello, and welcome to our live stream of the launch of our Circular Carbon Initiative, brought to you by the Office of the Vice President for Research. I'm Carolyn Unk, the Manager for Research Communication and Publication Services here at KAUST.
And I'm Dr. Nadia Karim, I'm Research Engagement Manager here at KAUST, and you are so welcome to be coming into our live stream today. We have had previous proceedings this afternoon from about 1 p.m. onwards, where we saw a plenary lecture from Bill McDonough. So do stay tuned until about 5 p.m. today. We will be talking about blue and green carbon capture, highly efficient solar cells, and many other things. And Carolyn, you had something exciting to talk to us about.
I do. Our colleague Xavier Pita, one of our extremely talented scientific illustrators and animators here at KAUST, has made us a wonderful animation to illustrate the work done here at KAUST on the circular carbon economy. So we hope you enjoy.
Enjoy.
Anthropogenic emissions, such as those related to industry and transport, are contributing to rising atmospheric levels of CO2. By developing technologies to manage this fugitive carbon, we can both reduce the human impact on the environment and produce valuable products. To do this, we need to move away from the traditional linear economic model of take, make, and dispose, and instead transition to a sustainable circular carbon economy that relies on reducing, reusing, recycling, and removing carbon. KAUST researchers are uniting to provide solutions for a viable circular carbon economy. For example, in concert with nature-based solutions, we are developing carbon capture technologies and exploring opportunities to safely store carbon underground. Meanwhile, combined efforts are aimed at optimizing energy harvesting from renewable sources such as solar and wind energy, while harnessing the potential of geothermal energy. Once harvested, renewable energy can be integrated to power carbon capture technologies and even to manufacture valuable e-fuels. KAUST, transforming fugitive carbon into a valuable resource.
Hello and welcome back. I'm joined here now by Kyle Lorson. He's an assistant professor in bioscience here at KAUST. Welcome, Kyle.
Thanks very much. Happy to be here.
Thank you. Thank you for sharing your time to talk to us about your research.
Yeah.
First thing I'd like to ask you, just in general, what is your work at KAUST about? And specifically, I know you work with algae, and the only time I think of algae is the pesky algae I had to get off of my fish tank as a kid. So how are you working with these algae for our benefit?
So I run a lab called Sustainable and Synthetic Biotechnology here at KAUST, and we do a lot of our work with algae, but we also do work with other microbes as well that can grow on non-traditional carbon sources. But algae are incredibly interesting because, like plants, they grow by photosynthesis. And so photosynthesis is where you use light energy, usually from the sun, and you use that energy to power the capture of carbon dioxide, the gas. And so all algal biomass is made of carbon dioxide. And so we try to do biotechnology with these organisms, whether it's engineering them or whether it's designing processes to grow them at scale so that we can capture more carbon dioxide and turn it into algal biomass. And then that algal biomass we can use to make a range of different products. So algal biomass has applications in feed for animals, in bioplastics, and biofuels. The list goes on and on.
Wow.
Yeah.
These guys are a lot more useful than I knew they were.
They sure are. They're much better than the, much more useful than the algae that you find in your pool, that's for sure.
Right, and the pool's the other place you find the algae
exactly,
you got to get rid of, and then use chemicals to get rid of the algae.
Exactly, yeah.
And so, once you, how do you capture this? How do you contain these, or what does it look like?
Well, it's a process called bioprospecting. So we go out into the Red Sea here and we take water samples and you concentrate them down. And because algae can grow with CO2, you can isolate them by culturing them in an environment where CO2 is the only carbon source. And so they can grow that way and outcompete whatever else is there. And then using microscopy and fine manipulation techniques, we can get those individual cells. And then because they're able to grow on their own and duplicate, they fill up a flask, or we can have a much larger volume of that isolated culture.
Okay.
Yeah.
Wow.
Yeah, it's pretty fun. We actually did an experiment with our lab where we isolated different algae from around our environment. So some of our students had some from their backyard pool, some had them from their cat feeder. Algae are everywhere. They're in every environment.
Wow.
It's just about encouraging them to grow. Yeah.
So you're working with KAUST algae?
We are now, yep. So we're specifically looking at getting algae from the Red Sea because it grows in salt water. And since we can grow them with sunlight and seawater, we can actually do an alternative form of agriculture right on the coast of the Red Sea. And this is a sustainable drive to increase bioproduction for having more of a bio-based economy and contributing to the circular carbon economy.
Okay, so this is how we get to the algae. So you mentioned they're like trees and that they use carbon. It's like a food source. But
exactly.
Is it a food source?
It
is. That fair?
It's their carbon source. Just like you and I have to eat sugar so that we can have a carbon source, algae have to eat CO2. So, yeah. Okay.
Can you tell us a little bit more of how that fits in then? So they're consuming the carbon and then...
Yeah, so all biomass is about 50% carbon. And algae sometimes are a little bit more, a little bit less. So when you do the ratio of carbon dioxide and how much carbon is in carbon dioxide and how much carbon is in biomass, you actually consume about 1.8 times the amount of carbon dioxide to make 1 unit of biomass. So 1 kilo of biomass is 1.8 kilos of CO2 that went into it. And so anything we do with algae is sequestering carbon dioxide from the atmosphere.
Wow, that's very cool.
Yeah.
Great.
Yeah.
And how would this link, if it does, to Vision 2030 for the kingdom?
I mean, in any push for increased bioeconomy, increased circular carbon economy, algae are one part of the broader spectrum of sustainable technologies that are out there. And so we look to increase the amount of things that we can do with these organisms. So we can engineer them to have non-native properties, make them produce things they didn't naturally produce, or we can find ways of creatively using that biomass in consumer products. And so what we're trying to encourage is people to use bio-based products that are produced in a sustainable way, and algae are one part of that.
Wow, fascinating.
Thanks.
So great. So thank you so much for coming to talk with us
My
today.
pleasure.
Thanks
Thank
so
you.
much.
Yeah.
Up next, we're going to have a short video from Carlos Duarte's work.
Seagrasses and mangroves are among the most productive ecosystems on Earth. These coastal marine plants use their leaves, roots, and tissue to absorb and store greenhouse gases like carbon dioxide while cleaning microalgae and other dead carbon matter from the sea. As mangroves and seagrasses grow and die, captured carbon, or blue carbon, cycles into thick layers of sediment on the seafloor, where it is stored undisturbed for centuries and even millennia. As far back as the Islamic Golden Age, researchers such as Ibn Sina or Avicenna have been studying the natural history of the Red Sea and the life cycle of its mangroves. KAUST researchers continue to build on this knowledge about mangroves and seagrasses in the Red Sea region.
At KAUST we have been studying mangroves and seagrasses across the Red Sea. We've studied 12 species of seagrass, also about 30 stands of mangroves all along the Red Sea. Mangroves and seagrass are able to lock carbon dioxide from the atmosphere and then put it in the sediments and the soils where they sequester this carbon over millenary time scales. They're also able to filter out plankton from the water column and settle their carbon also safely in their soil. This carbon accumulates over millennia and represents a major stock of carbon that is protected from being emitted from the atmosphere in as long as the habitat remains. So protecting mangroves and seagrasses is a very effective strategy to mitigate climate change. We have now discovered also another mechanism through which mangroves contribute to climate change mitigation, because mangroves, when they're set in a carbonate bedrock, like they are in the Red Sea, they dissolve the carbonate and release alkalinity that helps to trap carbon dioxide from the atmosphere into seawater. So the carbon sequestration capacity of these small mangroves from the Red Sea is remarkable and make them be the champions of carbon sequestration in the biosphere. Even though they look small and not much, they're really very important. They also play important ecological roles along with seagrass in providing habitat for biodiversity and also protecting our shores. So much of the fisheries in the Red Sea depend on the mangroves and seagrasses that provide habitat for the juvenile stages of those fish and also crabs and shrimp. So these habitats are very important and we refer to them as blue carbon habitats because of their very important role in sequestering carbon. Mangroves, because they sit in the interface between land and ocean, they're actually pollinated by a special species of bees from which we derive honey as well. So they do not only provide services at sea, they also provide services on land as well. Globally, we have lost about half of the global surface of mangrove and seagrass, but in the Red Sea they have been rather well conserved, and over the last 30 years we have documented a 13% increase in mangrove areas, and here in KAUST, due to the conservation measures that managers of KAUST have taken, mangroves have expanded by 20%, above the area of mangroves that was in place before KAUST was built. So restoring mangroves is very important as we enter the UN Decade of Ecosystem Restoration, and it's a major strategy to both contribute to climate change mitigation and also improve the health of our oceans.
Mangroves and seagrasses provide a home, food source, and nursery to marine animals and wildlife, including turtles, fish, sharks, dugongs, and many species of birds. Mangroves additionally prevent erosion and buffer coasts from storms. At KAUST, there are 900,000 square meters of thriving mangroves along the Red Sea coastline of the campus. These mangroves are a great resource for researchers and wildlife enthusiasts of all ages. KAUST is at the forefront of green and sustainable projects through innovative research and environmentally conscious management plans. Its vision and goals are helping to inspire environmental action from leaders in the kingdom and collaborators around the world.
Hello and welcome back. We're joined now with Daniele Da Fonkio. He's a professor of bioscience here at KAUST. Welcome, Professor. How are you today?
Very good, very
Great.
good. Despite the overall situation of the planet, I'm very good, yes.
Right, fair.
Here
Thank
is
you.
very comfortable and this initiative is very interesting.
Excellent.
Really.
Thank you so much for joining us and sharing your time to talk about your work a little bit here at KAUST. First, I'd like to ask you, I'm fairly familiar with your work from KAUST Discovery. We've done several stories together. So before I knew those stories, I just thought microbes were bad things and things that make us sick. But I know that they aren't. But I hope you'll tell the rest of the audience a little bit about that.
Yes, nowadays the microbes are not well perceived, considering the virus, pandemics, but most of the microbes do very good job for us. I mean, for the planet. They recycle everything, and what is our job is, our research mission is to understand how they do as a community, because they are very diverse, so there are so many, and we want to understand in the different extreme ecosystems, like the mangrove, for instance, how they manage the cycling of the nutrients, of the elements, and how they sustain the system. That is very important.
Are they essential to these cycles?
They are the key. They are the players.
They are the key
Yes,
players.
yes.
So it's not the trees themselves, the mangroves themselves that are doing this?
Yes, the mangroves, the plant itself needs, of course, the CO2 from the atmosphere, and that is the very interesting point because they can sequester it to fix carbon in tissues. But then they need nitrogen, phosphorus, and other elements that are cycled by the microbes. Many of them are fixed by the microbes. For instance, ammonia, that is the most important, one of the most important, is only fixed by microorganisms. So it can be provided to plants only by the means of microbes that fix it from the atmosphere. And what is important is that in the flow of the carbon, the CO2 is captured, is synthesized in, for instance, in the root system, and then this root system go deep in the sediments and are buried there, and the microbes can preserve that, cannot metabolize and leave that carbon in the sediment, so make a net sequestration of the CO2, the one that make the blue carbon at the end.
Okay, so if it wasn't for the microbes, then the plants wouldn't be able to sequester the carbon on their own?
For instance, what we are seeing now is that when the microbes are favored in their growth, for instance, by some oxygen that is provided by the animals that burrows in the sediments, like crabs, there is a bit more oxygen, and the oxygen is a burner. You know, everything is burned by oxygen through the respiration.
You mean it speeds it up, or?
No, I mean, if there is a lot of oxygen, the metabolism works faster, and
okay.
so there is an higher consumption and generation of CO2. But at the same time, the plant, the mangrove, Avicennia, grows much better and much more. So make longer roots, and at the end, the net results is the higher accumulation of carbon in the sediments. So some help from animals and the metabolism of microbes can help accumulating carbon in the sediments and increase the amount of blue carbon. That is very important. So what we are doing in our research is exactly this, try to understand these kind of cycles, this kind of cooperation between the different entities, the plant, the microbes, the animals that bioturbate the sediment, make these holes, these burrows that accumulate some oxygen, that re-engineer the assembly of the community, of the microbial community, so the plant can be favored, grow a bit more, or even much more, and so accumulate more carbon in the sediment and generate the blue carbon.
Okay, so with your research with microbes, you want to basically encourage the plants to do the job they're doing, but more and faster.
Yes.
Is that fair?
So by exploiting the natural process, like the bioturbation of the animals that rearrange the microbiome structure, the plant benefits. So we want to understand, first step is to understand exactly how this works, and then we understand we can leverage through the so-called microbial resource management. So we can manage the different microbes in the community to boost the growth of the plant and the accumulation of carbon. One of the most easy to understand strategy is to identify those microbes that promoted growth just because they produce fertilizers for the plant, or they produce hormones, plant hormones that can favor the growth, so increasing the speed of the lengthening of the root, etc. So these favor much more the growth of the plant that can be more productive and healthier. So
benefits all around
yes.
from these microbes.
Yes, and you cannot see really visually the things, but you can then measure that there is a very strong accumulation of carbon because of the sequestration from the atmosphere. So at the end is a net positive result considering the global carbon balance. And mangroves are contributing dramatically, it's very productive.
And that's a great contributor to circular carbon.
Of course, yes.
Yeah. Great.
Are among the most important type of forests that do this.
Mangroves?
Yes, mangroves.
More so than the rainforest?
Is similar, yes.
Similar.
Now I don't know the details of the rate of the rainforest, but from the studies I could understand that they are really very similar. They have a very fast growth rate, the mangroves, comparable to those, and can really accumulate a lot, because also facilitated by the semi-anaerobic or anaerobic condition in the sediments. When it is anaerobic, there is no oxygen, or there is very few oxygen, so the carbon that is stored there is not burned away back by respiration of microorganisms, so stay there and is buried until it became the blue carbon, the so-called blue carbon.
Sequestered underground.
Yes.
Nice and safe. Great.
Yes.
And in terms of Vision 2030, I think it's obvious then that these microbes contribute to the circular carbon economy, and in the larger picture of Vision 2030, would you say these microbes are important?
I say always we have to exploit the most. They are the most abundant form of life on the planet in terms of numbers, and in terms of biomass in the mangrove ecosystem, just to make an example, but it's the same in the others, other ecosystems. After the plant biomass, the microbial biomass is the biggest. So, and there are so many. So if we can leverage each of them to do a little tiny action, at the end the net result will be huge. And so that is the purpose, to exploit, to manage this resource, the microbial resource, to stimulate them to do what is needed for the planet at the moment, and at the same time allow us to continue to have sustainable economy, of course. And so I think that the contribution, that this can be the contribution. Now we know that Saudi Arabia is mainly made by deserts. The land is very desert. So there are two possibilities. One, exploiting the forests that there are here, that are not so many. One of the most important in Saudi Arabia is exactly the mangrove forest on the coast of the Red Sea or of the Gulf, on the other side, on the east side. So, and the other is the crops. So for instance, in the north of the country, there are intensive now new plantation of olive trees. Of course, there are the traditional oases with the date palm, and all these trees that have a long lifespan, because they can live for tens, even 100 years or more, they accumulate a lot of carbon in the root system. And so at the end, after growing and producing fruits, they also produce and accumulate carbon in the root system and in the soil. This is net sequestration as well. So they contribute, and what we are trying to do is to understand not only with what is happening at the fringe between the sea and the land, but also what can happen in this kind of sustainable plantation.
Okay. So have you been to any of these plantations in the
Yes, I've been
region,
in date palm oasis, and I'm going to go in, I hope soon, in the olive tree groves in the plantation. And previously I've made some research in other deserts like the Sahara, where there are this type of plantation, the oasis. And the oasis is unique because it's a system where there is, in the traditional management, there is the coexistence of multiple crops. The date palms make the screen from the top like a roof that keep the humidity, decrease the temperature, and favor the growth of a second layer that are made by fruit trees like olive trees, pomegranate, and other fruit trees. And on the ground, one can make the plantation of horticulture, tomatoes, or forages for animals, and this kind of stuff. So it's a very unique with a lot of biodiversity, both for the plants and the microorganisms. So it's really very, very interesting. Nowadays, that there is only the monoculture in many places. That is a system where you can really study the coexistence of multiple life forms at the same time, in the same place at the same time.
Right, nice controlled environment.
Yes.
But it sounds like in the date palm orchards where you're talking about, it's a very busy ecosystem above ground, but perhaps it's an even more busy ecosystem underground.
Oh yes, it is, definitely.
Great. Thank you so much for joining us today, Professor.
It was a pleasure. Thank you.
Thank you. Up next, we're going to have a look at Xavier Pita's infographic that he designed for KAUST Discovery magazine that we also are very happy to share with you here at the launch of the Circular Carbon Initiative. Xavier is going to talk a little bit about how he came up with his design for this infographic, what things he had to consider. So I'll let him talk about that, and I believe Nadia is going to ask him a couple of questions too. So please enjoy this chat. Thank you.
Thank you for inviting me for this, and thank you for the kind words about the infographic. I'm a scientific illustrator at KAUST, and my primary role here is to work with our researchers, finding ways to communicate their research in a clear, accurate, and visually appealing way. And I'm also fortunate and happy to collaborate frequently with KAUST Discovery. And among some other things, I have the responsibility of creating the main infographic for the magazine. And so in this latest issue, we created this infographic about the circular carbon economy, which was a fantastic piece to work on. So this process started a few months ago. Me and Carolyn Unk, the managing editor, we sit down, we collected information about the research that was going on at KAUST, and we brainstormed ideas. And it was clear to us that we wanted to highlight the research, we wanted to show how it impacted the real world, and we wanted to explain to our readers who might not be familiar with circular carbon economy what it is about and what it encompasses. From here, it started the more creative part of the process, and among sketches and doodles, I started to put together ideas. And so I had envisioned this two-part piece, one that addresses the explanation about the circular carbon economy, and the other that addresses the research that is being done at KAUST. So for the circular carbon economy, I had in mind a sort of a diagram where I could show through symbols representations of the 4 R's, the 4 strategies to address carbon. And little by little, this symbol started to become populated in my imagination by these figures of scientists and researchers that are literally capturing, getting carbon and storing it. And I found that this was a nice conceptual connection to the actual work of our researchers. So I developed that part of the infographic based on that. Regarding the research being conducted here, I try to come up with symbols, images that would evoke to our reader what the research is. And at an initial stage, I was not completely happy with it, because it seemed like these symbols, these images, these illustrations were disconnected from themselves and from the real world. So I tried to put them together in a landscape, a very conceptualized landscape, but it shows the reader that KAUST is working towards putting this research and its applications into the real world, and that all of these things can come together in a way that can create a more sustainable future and environment and society.
Excellent. And what you've done is not easy at all. This size of infographic with the, amount of contributions from KAUST, have you done anything of this caliber before, of this size before?
No, so at this size, no, this was the first. As I said, I frequently collaborate with KAUST, with the infographics, and we usually work with a lot of research, but it tends to be more focused, more narrow in terms of areas of research. This one was all over the place. There was research that covered all the different centers, all different divisions, apart from the sheer number of it. So one thing that made this infographic different is that we decided very early on that we would have to do it in a bigger format. And hence instead of the 2-page spread, we went for a 3-page spread because we had a lot that we wanted to show. There was a lot of research, excellent research being done at KAUST that we wanted to put out there and share with the rest of the scientific community and our society.
Excellent, Xavier. Thank you so much for joining us today.
You're most welcome.
And welcome back, everybody. We are sitting here still live streaming through the day at the KAUST launch of the Circular Carbon Initiative. I am Nadia Karim and I'm joined here today by a former PhD student, Sally Holmesy, but I should put a doctor in front of that name because you just passed your defence recently. Congratulations.
Thank you.
You're most welcome here with us today. So Sally, you work on cryogenic carbon capture technology with Professor Bill Roberts from the Clean Combustion Research Centre, right?
Yes, that's
Can you
true.
tell us a little bit about that technology?
Yes. So cryogenic carbon capture, it's a recuperative heat exchange process.
Brilliant.
So that allows cooling down flue gases to temperatures that would allow the CO2 to desublimate, and so then it can be collected as dry ice from flue gas streams from both industrial processes and also from power plants.
Okay.
And then because it is very recuperative in its heat exchange, it's pretty energy efficient compared to first generation amine type scrubbing technology, and it's expected to cost less than half the amount that amine technologies would cost.
Wow, brilliant. Yeah. So when we're talking about carbon capture, let's put that into context almost, because it just sounds crazy. When I think of CO2, I'm thinking of a molecule in the air. So we're capturing it at the source, right?
Yes, so capturing it from point sources reduces the energy penalty of the process. Can I tell you a little bit more about the advantages of cryogenic carbon capture?
Tell me everything. I'm dying to know.
All right, so the main advantages of cryogenic carbon capture is that in addition to capturing CO2, once you cool the flue stream down to these temperatures, you're also capturing the sulfur dioxide, the NOx.
So all the pollutants,
all the pollutants. You can get rid of the particulates, and you can capture the water in the flue gas stream for reuse as fresh water as well.
For our KAUST wider community, or anybody who's listening who's maybe a lay person, we talk about the flue gas stream. We're talking about maybe oil refineries. Is that what you're talking about when you say that?
So I should also mention that this technology has been demonstrated by our technological partners at 1 ton per day capture scale, and they've demonstrated it at both industrial plants, so cement plants, waste plants, and at power plants, and they've demonstrated it at coal-fired power plants as well.
Excellent.
So we have the rig right now at KAUST, and we are working to set it up for demonstration at a power plant in Rabech, where we'll be working with dirtier flue gases than it's been demonstrated at before.
Brilliant. Now you said Rabech very nicely there. Your Arabic is much better than mine, but Rabech's just a little bit north of us, right?
Yes.
Where there's many refineries. So the technology sounds very environmentally friendly, if I may say so. So then how does that contribute to a circular carbon economy?
Right, so it contributes to the removal portion of the circular carbon economy. And because, as you said, it is pretty environmentally friendly, all we're doing is cooling down the stream and then recuperating the energy. So you only really need to add in electricity for the refrigeration. So there's no heat required. You don't need to rely on hydrocarbons to fuel this plant. You can use all renewables. And also, you're not using any external material, so no sorbents or adsorbents or anything like that. So if you look at the full life cycle of the process, you're not contributing to CO2 in other areas while you take out the CO2 from the power plants.
Wow, so you've got the complete cycle almost. The complete circle, I should say, rather. So when we talk about your technology, we're putting it into the remove category of the 4 R's: reduce, remove, recycle, reuse, remove. Okay. And then how does that impact the kingdom? I'd say a lot, right?
Yes.
Yeah.
So we're removing it, and we're removing it from dirty flue sources that are currently available in the kingdom. And the way that the removal process also works, because you're separating it as a solid, you easily can melt it, and then you can pressurize it to high pressures that are required for transport to plants where you can reuse it or recycle and do other things with it pretty energy efficiently.
This is the CO2?
Yes.
So you melt it down, turn it into a solid. Once you've captured it, melt it down, turn it into a solid, and send it off somewhere else.
Yeah, melt it down, pressurize it to the pressures required for transport, and it's also through this process you get it at very, very high concentrations, so 99.99%. Low oxygen content, so you can use it for EOR and other uses around.
Wow. Okay, excellent. Thank you so much, Sally, for joining us today. And congratulations, Dr. Holmesy. It sounds very, very nice. And in the next clip, you're going to see that I spoke to Professor Mani Sarathi, Associate Director of the Clean Combustion Centre here at KAUST, where he talks to us about his McLaren collaboration.
Hi, good day. My name is Mani Sarathi. I'm an associate professor for chemical engineering at KAUST, and I'm also associate director of the Clean Combustion Research Center, where I do my research in the area of fuels and engines.
And Manny, if you could tell us a little bit more about the collaboration between KAUST and McLaren.
So the KAUST-McLaren collaboration was established in 2018, the summer of 2018, and it was primarily motivated by the need for McLaren to leverage upon KAUST's leadership in science and technology related to four key areas. The first is in the understanding of fuels and engines and in extreme environments such as a Formula One engine. The second is in aerodynamics research to improve the efficiency at which the vehicle travels on the track and improving the aerodynamics using computational fluid dynamics simulations. The third is about development of innovative sensors for measuring different parameters on the race car as it's zooming around the track. And the fourth is around data management, big data, and artificial intelligence so they can improve their optimization and decision making in race strategy. So these four key areas are areas in which KAUST has capabilities across our different divisions, and we provide these expertise in these areas to help essentially McLaren Racing perform better on the track.
And how does this collaboration contribute to a circular carbon economy?
So when we talk about a circular carbon economy, our goal is to mitigate carbon emissions to the atmosphere. And transportation or mobility accounts for about a third of global greenhouse gas emissions. Now, indeed, Formula One on its own doesn't contribute much to greenhouse gas emissions, but cars that go around all the roads, heavy-duty trucks, they contribute to these emissions. And Formula One is a platform for developing technologies, and in our case, low-carbon technologies, for eventual implementation in road-going vehicles. And to this end, what we're trying to do is to develop several key technologies. My main area of expertise is to develop low-carbon or zero-carbon combustion engines. And if we can make zero-carbon combustion engines by enabling the use of low-carbon fuels or zero-carbon fuels in these combustion engines in Formula One, then we can translate these technologies to light-duty passenger vehicles or heavy-duty trucks in the future. To this end, what we're aiming to do is we're developing novel formulations of things we call e-fuels or low-carbon fuels to enable the gas station of the future. So wherein you can go to a gas station and you can fill up your car with a carbon neutral fuel. And in Saudi Arabia, we aim to develop pilot plants for the production of these fuels in a project up in Neom at the Hydrogen Innovation and Development Center in Neom. We want to produce these fuels. And also we're working with the Ministry of Energy in Saudi Arabia to establish a roadmap towards production of synthetic fuels and low carbon fuels for mobility applications.
And how will this research impact the kingdom and align with Vision 2030?
So one of the ways we aim to impact the kingdom is first to ensure that hydrocarbons can be sustainable in the future. The kingdom is a large producer of hydrocarbon resources, and combustion engines and automobiles are also key users of hydrocarbon resources. Now, if we ever talk about engines, we think they're dirty, they're polluting, we need to get rid of the fuels. But our objective is to ensure that these engines can be cleaner burning, reduce the production of CO2 emissions. And in doing so, we can ensure that hydrocarbons used in those engines are also more sustainable, and we can sustain the markets for hydrocarbon fuels in the mobility sector. So besides even improving e-fuel formulation, we're looking at things like mobile carbon capture, capturing carbon dioxide. It is something we're also exploring, even possibly in Formula One, capturing carbon dioxide at some level and storing it on the vehicle and then removing it from the emission to the atmosphere. And how this aligns, of course, with Vision 2030 is these are all very innovative technologies. These are new growth sectors. Besides sustaining hydrocarbons or oil production and their use in mobility, we're also enabling the use of renewable energy in Saudi Arabia to be exported in the form of fuel. And this is essentially what places like NEOM wants to do, use renewable energy to produce these low carbon fuels or e-fuels and export these fuels to markets around the world. Similarly, Aramco wants to use low carbon hydrogen from fossil resources to make no carbon fuels like ammonia and export that around the world. So what we're doing is we're enabling the kingdom to develop its new industries around renewable energy, carbon capture, storage industry, so it can impact the mobility sector globally 2030 and beyond.
Well, next we are joined by Professor Stefan de Wolf from the KAUST Solar Centre. And Stefan, you're most welcome with us here today at the KAUST Circular Carbon Initiative. How are you?
I'm doing very well.
Good.
Thanks a lot.
Tell us, Stefan, what do you do here at KAUST?
At KAUST, I work on solar cells. I fabricate, together with the people in my group, we fabricate solar cells. We try to develop very high efficiency devices. And there's a couple of reasons why we want to do that. One important reason is that, globally, of course, photovoltaics is increasingly becoming important as a renewable energy source.
Absolutely.
One key thing, if you look at the market, is that the whole market is, of course, driven by price. But if you want to keep it low cost, actually you have to go to high efficiency, because then you will actually generate, more watt for actually lower price, which is kind of a key metric in the watt that you generate, for what you pay for it. So this is, short, but we have like different timelines, I would say, in our research. One, timeline is, I would say, rather short. So what we try to develop is, a silicon solar cell. So most of the market is actually silicon, like 95% of the
silicon solar cells
is silicon. So if you look at the module, typically in the field, anywhere in the world, it will contain probably silicon.
That sounds like the market's quite dense then, but is silicon just the best quality to use, the best
it's
material
a very good semiconductor, it's very stable, it's probably the most studied material in the history of science, I think, because of course microelectronics and so on, it's very well known, it's non-toxic.
It's non-toxic.
Non-toxic,
very
it
important.
has excellent properties, it's stable and so on. It's of course, we need to absorb sunlight, and actually, the properties. So it's a semiconductor, but a little bit technically, it has a certain band gap, which matches quite well the solar spectrum. So basically, it means that we will be able to harvest quite a lot of the solar photons. With silicon.
So when we say silicon is stable, we mean to say that it can last long?
Yeah, if you look, typical module, commercial module, a company will give you 25 years warranty. Name me one other product that has similar warranty. It's incredible, I think.
Very good.
But of course, it's very important also. We don't want to have every 2 years to have to renew completely our solar plants.
Absolutely not. I wouldn't want you coming along to my house, my new house, where I've just put solar cells on it.
I will not do that.
And take them down after 2 years. So this is your solar cells that you have developed in your lab here in your hand.
Yeah, and there's something, there's a couple of things particular about it. So as said, efficiency is very important. Every company tries to go to higher and higher efficiency.
You've reached quite high efficiency with these solar cells.
We do.
Why are you being modest? You've reached quite a high efficiency.
But the technology that we use, and let me very briefly explain. As said, it's like most of the traditional PV panels will use already silicon as a photovoltaic absorber, so the material that converts the sunlight into electricity, but you also need to make contacts because you need to get the current out of the device.
Okay, so let's break it down for a little bit layman's terms. So the device needs to be able to take in the solar rays to produce energy, but it also then will store this energy. And there needs to be a way.
It will not store, a solar cell will not store the energy, it will convert
the energy, but then what are you saying afterwards? So
there are two things important. One is you need to absorb the sunlight, and actually what you do, a little bit technical again, you will excite electrons into higher energy state. And then you need to still get them out. And for that
after exciting these electrons, then they need to be released.
You need to get them out because you want to have current flowing out of your solar cell. That's why we have for instance, the white lines. This is metal. This is, this will be stringed together into a module. This is how we get, the current out of the device. And as mentioned with the traditional silicon solar cell, what you will have is that the metal directly makes contact with the silicon. Which gives you really good contact, but also it gives you some voltage losses because you have defects naturally. And so the device that we make is a little bit different. We call it a heterojunction cell.
Heterojunction.
What we actually do is we coat, with specific semiconductors and materials again, very thin layers we coat on top of the surface that we take away all of the surface defects. And basically the metal is, I would call it displaced with a few nanometer from the silicon
So
itself.
you're not then touching the metal?
The silicon wafer does touch the metal, yeah. I mean, that's
Okay.
the particular thing
Right.
about this technology. And with this, we can go to, efficiencies very close to what is theoretically possible with silicon alone.
Excellent.
But of course, I mean, the question then comes, is this the end of PV? Is the end of development? No, it's not. We need to go to even higher efficiencies. I mean, because
Wow.
again, it's the same reason the market needs and is driven by high efficiency, because it really brings down the cost of the generated electricity down. And for that, I mean, what we develop now, and that's a little bit our longer term research, as that silicon absorbs quite well the solar spectrum.
Yes.
But actually, if you look, I mean, we have an important part of so-called blue photons, more in the UV part, so more energetic photons.
Okay.
And there we do convert them into electricity, but we also generate some heat.
Okay.
We cannot convert all of the energy of the photon into electricity.
So is this a good or bad thing, generating heat?
It's not the best thing.
It's
no.
not the best
It's
thing.
not the best thing. So it's something you want to avoid.
It's a challenge.
Yeah, and one way how to avoid that
Yes.
would be, and that's what we work on, we try to develop basically, I mean, what we call a tandem solar cell that consists of like silicon on one hand,
Okay.
and we put on top of it another semiconductor,
Tandem solar cell.
tandem. So,
Silicon semiconductor.
and the other semiconductor is called perovskite. So it's like quite
Perovskite.
perovskite. Yeah, it's a quite
I'm not
new
going to try and say that again.
perovskite. But it's quite particular semiconductor. It has like incredibly good optoelectronic properties.
Okay.
And still, what we can do is like, we can simply process it from solution. So we can, I mean, in the lab, we spin coat, or I mean, with certain techniques, we can coat a substrate. It's still solution, it crystallizes, and it becomes a very good semiconductor.
Okay, excellent.
And that's very attractive to make tandems, because what we try to do now, and that's, I mean, the small device that I have here, this is one of the, I mean, of course, we start small and we hope to go big quite soon.
And you will go big, I think so.
Let's see, but I
you
think,
will.
I mean, we have everything, to do that. I mean, this is a device that we make now already at KAUST, only silicon, so we are really aimed at like,
That's quite
aiming at
impressive
large,
that you developed that. Okay, so tell us a little bit about this smaller device.
And the smaller device is basically, it contains the same silicon, the same what we would call bottom cell technology. So it's also a silicon heterojunction cell, but on top of it, we coat it with a perovskite cell and also with its specific contacts. So again, you see, the white lines. This is again the metal. But now these are actually two solar cells on top of each other, but they're completely like, made like maybe like a cookie, a layered cookie.
Okay.
We call it
Can
a
eat it like a
monolithic
cookie.
tandem cell.
Okay.
And
what's the advantage of having two solar cells, one on top of the other?
But again, the main advantage is that the top cell will harvest very well the blue part of the solar spectrum, and the bottom cell, the silicon, will harvest very well the red part of the solar spectrum. And that means that actually the theoretical efficiency of this device is maybe, for silicon at least 29%. For this device, theoretically, it can be 43%. And
that is extremely high, right?
It is. It is. It would be
it's very impressive. Let's move out of the technical side of things. How important are renewable energies? How important are solar cells for the future in a world where we're working towards a more sustainable future and a circular carbon economy? How important are your solar cells?
Well, renewable energy, of course it will be, a combination of many technologies, but renewable energy in the form of photovoltaics, solar cells, is of course, I would think a key component, and it's a technology that exists already for several decades, but it's really, especially since I would say the late 80s, that it really, has become,
it's been around for a while.
But it's also one of the fastest growing industries. Still, every year the industry is growing by 20%. Now it's a multi-billion-dollar industry,
wow.
So we have like a global production capacity of over 100 gigawatt.
Wow. Okay.
Which means that, basically, if everything that is being produced annually, it would mean that every year 100 gigawatt of panels are being installed in the world. which also means that, I mean, soon we will have like globally 1 terawatt of photovoltaic capacity, which, I mean, starts to become a significant number, so it's really
pretty impressive as well.
Growing fast, and also here in the kingdom, it's I mean, it's very exciting to see. I mean, with programs especially such as Vision 2030, that I mean, you see a lot of positive
you do. I don't
developments and large solar plants. I mean, it's not only the announcements that you see, but also, I mean, they are really, I mean, physically, I mean, installed plants now. Like the largest one, the first one was 300 megawatt.
We had the first one in the kingdom, I think, didn't we have something like this?
Yeah, it was like last year went online, and but also, I mean, you have solar, but you also have like imported wind plants and so on. So
it's happening, and the future is renewable energies. And I think it's renewable energies plus the use of fossil fuels, plus the use of other technologies to contribute to a circular carbon economy. It's a multitude of different avenues to go down. But I mean, as you said, it's everywhere. And it's like, I know that my parents back home in Ireland, you know, they've been offered a grant if they put solar cells on the side of their house, right, to reduce the energy consumption in their house. And everybody is moving towards reducing CO2 emissions in some capacity or another. So I think what you do is extremely important, especially for the kingdom and the world.
Well, here in the kingdom, it's of course, I mean, we have like, I mean, there's so much sunshine.
There is like a lot of sunshine.
But compared to Europe, it's
rains about 2 days a year here in Jeddah, anyway, where we are.
A little bit of rain would help with the dust, but I mean, KAUST is also working.
Dust is another issue, that's for sure.
KAUST is working on solutions for that with Nomad.
KAUST are, yes, indeed, with Nomad. I'm interviewing them later on today as well.
Yeah. But here we have like more than twice the amount of sunshine compared to Europe, which of course means that, I mean, with the same panel, you will generate more or less twice the amount of electricity.
Right.
But the price of your panel or of your PV system is the same. So PV price here will be much cheaper. And that's also what you see now. I mean, with the large PV installations, I mean, within the Vision 2030 program, that they come to record low PV prices here. I mean, globally, if you compare to, I mean, globally, that it's very attractive to see that. And I mean, hopefully, with what we can do here, we can also make our contributions, and that, I mean, we go even lower in price.
Absolutely.
And that's, I think, I mean, very exciting, because if you look at, I mean, projections for like, it's not only that, I mean, globally we will consume more and more electricity, but also energy. And of course, it's like, if you have such cheap and abundant renewable energy or electricity, I mean, it opens opportunities to really start to electrify largely the energy sector, and certain energy sectors that I think in the past people never would have thought, I mean, you would like to electrify, become, I think, a possibility. And I mean, one is already simply like, if you look at cars, I mean, simply, I mean, charge them at home on a PV panel, or charge them at KAUST or at your job on a PV panel. And
I think you're going to do pretty fine in the future anyways. The sector is there for sure, and it's here to stay. And Professor Stefan de Wolf, thank you so much for joining us today. I think we could sit here all day talking about photovoltaics, but thank you very much.
It has been a pleasure. Thank you.
My name is Daria Baran, and I'm the co-founder of IRIS. IRIS is a startup that produces transparent solar panels for future buildings and greenhouses. We are creating glass that can generate electricity and provide power to multiple areas. This technology doesn't exist in its commercial form yet. We believe that IRIS can be the technology for the future of energy.
Okay, and welcome back everybody. We are now here with Professor Martin May. He's going to introduce us to geothermal processes. Martin, introduce yourself. What do you do here at KAUST?
Hi Nadia, it's good to be here.
Thank you.
Thanks for the invitation. We work on geothermal energy to make this part of the energy mix in the kingdom. And I've actually been looking at that since about 2014, 2015.
Okay, for a while now.
Yes, when this first came up. Interestingly, by local stakeholders like Mecca Municipality.
Oh, wow.
Or SEC, the Saudi Electric Company. And they wanted to assess the geothermal potential in the kingdom. Now, I've been at KAUST since 2009, so I've been in the kingdom for quite some time. My main research is actually not geothermal energy, but the earth structure, earthquakes, so geological and geophysical process
Very
as a whole.
interesting.
When I talk about geothermal in the kingdom, you may think, wait a minute, geothermal energy, that's something I know from New Zealand, from Iceland, where you see geysers, right, and hot steam coming out of the ground. And then eventually it was realized you can use that for producing electricity. It's not quite that fancy in Saudi Arabia, but there is heat in the ground everywhere.
Yes.
And in fact, if you drill a hole, let's say at KAUST, and put a thermometer down there, you will...
How far down?
Yeah, so that's what I'm going to say.
Oh, that's where you're going.
Then, you will see that the deeper you go, the higher the temperatures will be. And this geothermal gradient is about 30 to 35 degrees per kilometer.
Per kilometer, wow.
Right. So if you drill 2 kilometers or 3 kilometers down, you are at about 100 degree, 80 to 120 degree
right.
temperature.
How do we tap into that? So basically geothermal energy, right, deep below the Earth's surface. But how then do we tap into that and bring it out into our everyday lives?
Right. So there is water down there, or in the eastern provinces, Saudi Aramco has been producing oil and gas for decades. That is actually at very deep depth, and so has high temperatures as well. So you can use, if you have abandoned wells or dry wells, and actually pump water down there, or use the deep in situ water to bring the energy to the surface. Now, water is not the ideal carrier of temperature. So another alternative is to use CO2. So you mix CO2 with water, which makes that combined fluid a better, we call it wicking fluid, because it can transport the energy more efficiently to the surface.
Brilliant.
So in essence, one way to think about using this deep geothermal energy that simply exists is there because it is part of the earth and it's continuously renewed by the earth itself. You use water or a mix of CO2 and water to bring out that energy. And if you take CO2 that's generated in industrial processes, right, you basically sequester the CO2 at depth and you utilize it to produce energy from the earth.
Okay, so when we talk about a circular carbon economy, we always talk about the 4 R's. Which R are you talking about when you talk about geothermal energy? Is it reduce, remove, recycle, reuse?
So I can say we are reusing the CO2.
Okay.
So we put this to a good use.
Yeah.
Yeah.
Sounds
So
like it.
Instead of blowing it into the atmosphere,
yeah, nobody wants that anymore.
We can reuse the CO2 at depth. And then we have a component to it which is a little bit more complicated to explain, because we can use this geothermal energy for processes where we typically utilize a lot of electricity for, like desalination or cooling system, district cooling. So if you want to cool a shopping center or KAUST or whatever, you create that energy not from electricity, but from geothermal. So you would avoid burning fossil fuels in the kingdom used for producing electricity, and instead use the geothermal energy to drive your desalination plant or your district cooling.
Brilliant. And it sounds really relevant for KAUST or Saudi Arabia as well, these arid regions where we need a lot of cooling in buildings and everything. So is it something that we should be tapping into in the kingdom?
Absolutely, absolutely. That's what we are working on here in the kingdom, in KAUST. In the kingdom with stakeholders at other universities, KFUPM, KAU, KSU. We have connections to the Saudi Geological Survey. We tapped into KCARE, King Abdullah City for Atomic and Renewable Energy. So there has been quite some discussion over the years.
Okay.
We're beginning to aggregate in teams and try to understand what exactly needs to be done and when and where. So what are, let's say, prime target regions?
Yeah, because I can imagine there's different places within the country that would be better for drilling down such a...
Precisely,
Yeah.
or where we think we have what we call the high heat flow.
Right.
So where we have geologically prominent areas that are promising to geothermal developments. And in this context, we have identified essentially the coastal plains along the Red Sea with some let's call hot spots, right?
Okay.
Down in Alith is well known. There's some geothermal hot springs at the
Alith
surface.
down south on the west coast, yeah.
Also near Jeddah and KAUST, the Al Waj platform, where there's one of the mega projects. The Red Sea project is there. Also the Neom area. So specific spots where we are along the Red Sea. We have good evidence from a lot of geophysical data that there's a high likelihood for high temperature gradients. But then you need also the right geology, what we call sedimentary basins, where you have permeable rocks that can store a lot of water.
And so then you can actually drill down to it. I mean, I don't know, can you cause a seismic activity if you drill down? Do you have to be very careful about, being on tectonic plates or something like this?
That's a good question. If you just drill, you don't create any seismicity.
Okay.
Seismicity is generated when you want to, what we call, enhance your reservoir, or you want to fracture it to prop open cracks for fluid transport. That's also done in oil and gas reservoirs in the Eastern Province. Now, the earthquakes in Saudi Arabia, they're elsewhere. They're in the Red Sea and they're up to close to the Neom area.
Are there actually earthquakes in Saudi Arabia?
Oh yeah, there are plenty of earthquakes, but they're mostly small.
Oh, okay.
Yeah.
I've definitely never felt one in my 3.5 years.
Okay. No, I didn't ever feel an earthquake in Saudi Arabia, but elsewhere. Now, but back to your question, if we drill for geothermal reservoir, the way we think about this, if we're in sedimentary rocks, let's say in sedimentary basins along the Red Sea shores, then the chance for earthquakes is minimal, if at all, because we are not in a tectonic setting and a depth where this would be a problem, and the way these geothermal systems would operate, they don't do the fracking. This is what you know from United States and Texas and so on, where you try to prop open your reservoirs with high pressure fluids that you pump down that then cause the earthquakes. But that's not needed in our application.
In getting access to geothermal energy.
Right.
So it sounds like there's definitely potential for it here in the kingdom. That sounds like it's starting, no doubt. You guys have checked out you've done the geological surveying.
We're on it.
You're on it.
So this is where we need help.
I trust that you're on it.
Yeah. So this is where we need the collaboration in kingdom. This is where we need the different stakeholders, like institutions I mentioned earlier, to collaborate, because these are big projects. But also there's a lot of data in the kingdom already, which resides with Aramco and others. And so this data would be extremely helpful for us to pinpoint where to do the more detailed surveying, where to put more resource or dedicated drilling for the geothermal potential assessment.
And I think I said it yesterday too, that's exactly what this initiative is all about, right? The Circular Carbon Initiative from KAUST. It can't be a one-man job. This has to be, everybody needs to get involved in contributing to a circular carbon economy. And here at KAUST, we are asking to collaborate with our internal and our external stakeholders in the kingdom, outside of the kingdom, to create a more sustainable world. So it sounds like you're asking the exact same thing there.
I think we all understand that this effort and this Vision 2030 is something that brings together a lot of people and has to bring together, because there is no isolated solution.
No.
And I have to say also, this event yesterday and today is really opening doors. Just a few moments, or let's say 2 hours that I've been around now at the booth, we have already clients, visitors, interested people coming from different companies and asking some very, very profound questions. And so that's exactly what we need, these kind of venues for interaction.
Delighted to hear that. I think we could sit here all day, but I have to let you go. So thank you so much, Martin.
It's been a pleasure talking to you, Nadia.
Thank you.
Take care.
Welcome back, everybody, and I am joined now by Professor Matteo Parsani. Matteo is actually from the computing side of KAUST, but he's going to talk to us about his collaboration with McLaren. Matteo, you're most welcome.
Thank you, Nadia. Thank you for the invitation. Good, very well.
Good. Tell us about yourself. Tell us what you do here at KAUST.
So, I'm a professor in applied math and computational science, and I'm a member of the Extreme Computing Research Center. So, I do computations, big, large-scale computation. And before joining KAUST, I was for about 3.5 years in the US working for NASA.
Oh,
and then
very impressive.
Yep. And then I came here again as a professor, and I started my career here as a faculty.
Yeah, and it seems to be going very well because you have this collaboration with McLaren now.
Yes, it started in early 2018.
Right.
I believe. I'm taking care of the aerodynamic part of the car. Specifically, during the first year, we were focusing on the front wing, which is the one of the wing of the car that generates the downforce.
Brilliant.
It's a crucial, part of the overall car and aerodynamics. And later this year, we started to do simulation around the full car. It's a full car from the 2017. It's the same car that you can see down in the foyer.
Yes, a lot of people have been seeing online and physically here this picture of this gorgeous Formula One car from McLaren. So you work on that car?
Yes, they provide us the CAD, so the geometry. We mesh it and we run it. We are running it actually on Shaheen. It's about 1 trillion of points. 1 trillion. So 10 to the 12 points where you compute your solution.
What does that even mean?
What we wanted to know is how the air moves around an object. Could be a Formula One car, could be an airplane, could be a golf ball.
Okay.
And based on how the flow moves, it generates aerodynamic forces, and you want to reduce some of them, specifically the drag, when you are on a straight with a car, because you want to go fast. But at the same time, you don't want to take off, because a Formula One car is actually, if you flip the car and it goes at the speed of 300 km/h, it could fly. That's actually, the aerodynamic of a car.
Okay, so when I think about a circular carbon economy, I don't know if I really associate that with a Formula One car. Can you help me out here a little bit?
It's not a straight link that you can do, or that I myself do, but basically, a general car, a road car, on a highway consume about 50% of the fuel because of the drag of the aerodynamic drag. So you have to win the aerodynamic drag in order to go forward.
Okay.
50% of the fuel on a highway.
Wow.
On a city is much less, it's about 20%. But if during the design process, for instance, you can gain 10% of aerodynamic on a highway, these translate in 5% of fuel saving. So what's the link with the Formula One car? Well, a Formula One car is aerodynamically almost a perfect object.
Right.
And it's very, very tough to improve the aerodynamic of such an object.
Why is it so perfect?
Well, it's people have been using for a long time cutting edge technology,
right.
Both for engine aerodynamics. And in a Formula One car, every year the gain that you get in terms of timing per lap, 50% comes from the aerodynamic of the car, then about 10 to 15% engine, then tires, and then of course the pilot. So it's really a crucial aspect of the car.
Like
And every year trying to bite a little bit,
little by little.
A little by little. It's it's going to make the object almost perfect. So the goal of McLaren, or in general of a Formula One team, is to gain 0.1 second or 0.05 second per lap.
Wow.
So you can imagine that you're seeking the perfection. So if you can succeed in a Formula One car, simulating and improving the aerodynamic, then you can really trickle down the technology, the computational technology that we develop to a road car. That's the link between
and therefore reducing the amount of fuel and the amount of CO2 that the car or
Correct.
the vehicle emits.
Yes.
So if we were to categorize this, I'd put it into the reduce.
Correct.
Category.
It's the reduced category. Yes.
Yeah, no, it does sound. I'm getting there now. I'm making the link. It does sound fantastic what you do. Just thinking about the kingdom itself and for Saudi Arabia, how does your work impact the kingdom?
So some part of the 2030 vision, they mentioned that they would like to have their indigenous development of airplane, drones, flying vehicles. This is not present right now in Saudi Arabia, and we are contributing, and we will contribute in training students, training scientists in this field, and get ready maybe to go one day to work in a Saudi company where they develop aircraft, maybe not completely an aircraft or part of it. And this is, the impact that we have on the long run. On the short
very significant impact, mind you, as well.
Yeah. Hopefully. In the short run is the training of the student right now that they go out, they can, get additional training outside, maybe, other university where they have aerospace program, or where they are interested in computational fluid dynamics, in aerodynamics, and maybe then bring them back with, stronger bone to do something here in the country.
I don't think they need too strong a bone anyways to work for you.
Oh yeah.
Maybe for KAUST. Although you did work for NASA. Matteo, thank you so much for talking to us today about your
Thank you for the
research.
invitation, and I hope you enjoyed it.
I did. No, I did. Thank you so much.
Thank you.
Great.
So when it's red, it's done, right? How was Alex?
Since the early 2000s, global leaders have been collaborating to collectively address the challenges of climate change. So it is imperative to adopt a holistic approach towards carbon. The Circular Carbon Economy Framework is a compelling and effective approach to address climate challenges through all available technologies across the 4 Rs: reduce, reuse, recycle, and remove. Unlike the linear framework where carbon is released into the atmosphere, the CCE framework aims to achieve carbon balance by closing the loop. Reduce CO2 through energy efficiency, renewables, and alternative fuels. Capture the emitted CO2 and reuse it for alternative purposes such as soda drinks. Recycle the captured CO2 and alter its chemical composition to produce fuels, chemicals, and fertilizers. Remove CO2 from the atmosphere through carbon capture as well as nature-based solutions. CCE takes into account different national circumstances while striving to meet the global shared climate aspirations. Today, Saudi Arabia has adopted many measures to accelerate momentum through various initiatives across the 4 Rs. Renewable energy is expected to represent 50% of the kingdom's power mix by 2030. Saudi Arabia achieved the lowest cost of solar energy. Saudi Arabia plans to develop the world's largest hydrogen-based ammonia production facility in Neom. It will supply 650 tons per day of carbon-free hydrogen. Saudi Aramco facility in Hawiyah captures CO2 that is then piped to an oil reservoir for enhanced oil recovery. SABIC established the world's largest CO2 purification plant. Purified CO2 is used in agricultural nutrients, medical applications, food and beverages. Saudi Arabia launched an ongoing afforestation campaign to plant 12 million trees by the end of this year. Today, Saudi Arabia leads hundreds of CCE initiatives with stakeholders from both the public and private sectors. And that is just the beginning. It is a collective, shared responsibility to react to the climate emergency in order to safeguard our planet. Together, we must do better.
أصحاب الجلالة والفخامة والسمو والدولة، المشاركون الكرام،
السلام عليكم ورحمة الله وبركاته. يشرفني أن أرحب بكم في الفعالية الصاحبة الثانية حول الحفاظ على كوكب الأرض بإطار الاقتصاد الدائري للكربون. في الوقت الذي نتعافى فيه من داعيات الجائحة علينا أن نهيئ الظروف التي تكفل إيجاد اقتصاد قوي وشامل متوازن ومستدام من خلال تمكين الإنسان والحفاظ على كوكب الأرض وتشكيل آفاق جديدة لاغتنام فرص القرن 21 للجميع. إن الحفاظ على كوكب الأرض يعتبر ذا أهمية قصوى في ظل زيادة الانبعاثات الناتجة عن النمو الاقتصادي، وعلينا أن نكون رواد في تبني منهجات مستدامة وواقعية ومجدية تكفل لتحقيق الأهداف المناخية الطموحة. من هذا المنطلق تشجع رئاسة المملكة إطار هذا الاقتصاد الدائري للكربون التي يمكن من خلالها إدارة الانبعاثات بنحو شامل ومتكامل يهدف تخفيف حدة آثار التحديات المناخية وجعل أنظمة الطاقة أنظف وأكثر استدامة وتعزيز الأمن واستقرار سوق الطاقة الوصول إليها، حيث يتسنى الدول تبني وتعديل التقنيات التي تتناسب مع المسارات التي تختارها الدول لتحولات الطاقة، وذلك من خلال ركائز الاقتصاد الدائري للكربون، حيث تشكل هذه الركائز مجتمعة نهجا شاملا ومدا كاملا وواقعيا يتيح الاستفادة من جميع خيارات إدارة الانبعاثات في جميع القطاعات. وستقوم المملكة بإطلاق البرنامج الوطني للاقتصاد الدائري للكربون لترسيخ وتسريع الجهود الحالية لتحقيق الاستدامة بأسلوب شامل، وندعو الدول الأخرى للعمل معنا لتحقيق أهداف هذه البرنامج المتمثلة في التصدي للتغيير المناخي مع الاستمرار في تنمية الاقتصاد وزيادة رفاه الإنسان. في عام 2012 أطلقنا البرنامج الوطني لكفاءة الطاقة في جهود تقليل الانبعاث ضمن مبدأ الاقتصاد الدائري للكربون، وكذلك لدينا العديد من المبادرات المعنية بالتقاط الكربون وتحويله مواد خام ذات قيمة، ويشمل ذلك المنشآت الأضخم في العالم من تنقية ثاني أكسيد الكربون، والتي نشأتها الشركة السعودية للصناعات الأساسية سابك بمقدار 500,000 طن في السنة. كذلك خطة أرامكو السعودية لاستخراج النفط بمقدار 800,000 طن من انبعاثات ثاني أكسيد الكربون في السنة. وعلى غرار ذلك نعمل على تطوير أضخم منشأة الهيدروجين الأخضر في منطقة النيوم. وإدراك من المملكة الدور المهم لعملية امتصاص الكربون من خلال الطبيعة، وقد نادينا بتبني هدف طموح يتمثل في الحفاظ على 1,000,000,000 هكتار من الأراضي المتدهورة واستصلاحها وإدارتها بنحو مستدام، وذلك بحلول عام 2040. إضافة إلى ذلك من لدينا خططنا كبيرة لمصادر الطاقة المتجددة، ويشمل ذلك طاقة الرياح والطاقة الشمسية التي تتمثلان ما نسبته 50% من الطاقة المستخدمة لإنتاج الكهرباء في المملكة بحلول 2030. وفي هذا الصدد سوف نستمع الآن من أصحاب الفخامة ومبادراتهم وطموحاتهم المختلفة في هذا الشأن.
Welcome back, and I think you just saw a really nice video there from the Ministry of Energy with His Royal Highness King Salman, where he was endorsing the circular carbon economy, and that is exactly what we are trying to do here as well, is to demonstrate KAUST efforts towards a circular carbon economy.
So I'm now joined by Mr. Sanchez. You're most welcome.
Thank you very much.
Co-founder of Nomad Solar Technologies.
Sorry, say that again?
You're from Nomad Solar Technologies.
Yes, correct, yes.
You're most welcome with us today.
Thank you so much.
Tell us a little bit about yourself, Aaron.
Yes, so I basically came to Saudi as a master's student in 2015. Then I did my master's for 2 years, and I had the opportunity to have an internship with Nomad at that time, towards the end of my master's. And then they offered me a job, and it was a great opportunity. And ever since, I've been in Nomad for the last 3.5 years.
Excellent. Sorry, I must correct myself. I thought you were a co-founder there earlier. But no, you're not.
Thanks for that.
So Nomad Solar Technologies. Tell us
Yes.
a little bit about this. Well, I'm thinking solar panels are everywhere, right? What is what's so special about Nomad Solar Technologies?
Yes. So in Nomad, we are a company that we develop and create robots to clean solar panels. It's a dry cleaning. So it's the future, basically. I mean, there's big projects in Saudi. Solar is going really big everywhere, so it's the future. But you need to find a way how to clean the panels. And you have different options. You have manual cleaning, so you have to use labor, you have to use people. You can also use other robots, but a robot is very resilient. It was designed here in Saudi, tested for the last 8 years.
Wow.
In the right conditions, where you have a lot of dust and extreme heat as well. So that's a very important thing to take into consideration. So that gives us a lot of advantage over the different competitors that we have.
Oh, okay. We'll talk more about that in a minute. So it's not the solar technology itself that you guys have developed, but it's more so this robotic hand that kind of waves over the solar panels. And the reasoning for that is because it's cleaning it. Essentially.
That's correct, yes.
Because we live in such a dusty, arid country where there's a lot of sun, but hey, there's also a lot of sand. And so we're not going to increase labor and get people out there cleaning it with a cloth. You guys have actually developed a robot to do this.
That is correct.
Yeah, that's brilliant.
Yes.
So have you done any field testing in the kingdom at all?
Yes, so Nomad was founded in 2012. And ever since that time, we have been doing different testing in Saudi, also in the Emirates. We also had some deployments for testing and technology evaluation in Spain and in India.
Oh, okay.
So different locations, but basically for the last 8 years in Saudi.
Brilliant.
Yeah, in these extreme conditions.
Okay, so let me imagine this. Your robot is on solar panels in the middle of a desert.
Correct, okay.
How is the robot then powered?
Pilot.
How is it powered?
Powered, okay. Yeah, good question.
Okay.
So our robots are completely independent. There is an onboard battery in every robot. There's one solar panel that charges that battery, and then there is a set of electronics that basically control what the robot does. The program to control the robot and the interface to control the many robots in one of your sites, let's say, one of your solar plants, it's completely developed by us. So it's been our technology for the last years, and we have been doing a lot of improvements on that, so it's really optimized for the application, basically.
Oh, very good.
But the robot by itself is completely independent. So even if the robot faces some obstacle or something, it has the intelligence to overcome it. And then you will receive alerts on your phone in any place where you are in the world, and you can have basically a live feed of what is happening on the robots. Independently, you can even see the voltages, the charging current. Wow. It's really, really advanced and really, really great.
So you're integrating renewable technology with artificial intelligence and autonomous technology, basically.
Autonomous technology,
yeah.
Yes.
Oh, that's pretty impressive. Yes. Okay, so you touched on it. You have competitors. How does your technology compare to others in the field?
Yeah, that's a really good question. So the most important point there is that we were designed and tested in these conditions. Some of our competitors come from China, from some other places, but they were not tested in these conditions. Really, we have been here for the longest, and we are a Saudi company, so we have all those all that background to support our technology here. So that makes us puts us ahead of the competition. But besides that, all this testing, all this technology evaluated in the right conditions, we have our monitoring system, which is called Chief, and this is software we developed by our team. And it's really, really much more advanced. As far as we know, it's the most advanced monitoring system for robotic cleaning in solar plants. Yes.
Thank you. And as they say in the kingdom, mashallah.
Mashallah.
Yeah, that sounds brilliant. Aaron, thank you so much for joining us here today. I wish you all the best with Nomad Solar Technology.
Thank you so much, Nadia.
Okay, so this brings us to the end of our day today, and thank you very much for listening to us live streaming for the last 2 days. It has been an absolute pleasure. Carolyn, how do you think it's been going?
I think it's been great. Action-packed couple of days. Thank you so much for organizing all of this. It's been a treat to be involved. I learned so much, had so many great chats. Wonderful to speak with so many faculty members about their work. So
that's good.
Excellent event.
Thank you. No, thank you for being part of it as well. And I think I just hope that we truly have demonstrated KAUST efforts towards a circular carbon economy, and that's the importance of this as well. And basically saying that it's not, you know, one size fits all. It's not one person job. It's many people that are needed in this. We're all in it together. We all want to make a sustainable future. And if you want to learn more about what KAUST is doing towards the circular carbon economy, you can go to cci.kaust.edu.sa. We thank you very much for joining us for the last 2 days, and yeah, good evening.
Thank you.
The circular carbon economy is a sustainable way of approaching energy and climate goals. It implicitly values all options and encourages all efforts to mitigate carbon accumulation in the atmosphere while facilitating global economic growth. Inspired by nature, it is a closed-loop system where carbon emissions are reduced, reused, recycled, and removed to restore the balance of the carbon cycle. KAUST is catalyzing the circular carbon economy by contributing scientific advances in the development of engineering, chemical and biological technologies, in addition to clean and traditional energy solutions, which include hydrogen fuel and other advanced materials. The city of the future efficiently manages energy production and use. KAUST researchers are developing technologies by integrating next-generation solar cells with efficiencies greater than 28%, hydrogen production, smart decentralized wastewater treatment, novel air conditioning, and energy-saving lights for smarter homes and neighborhoods. Artificial intelligence technology further supports city-scale planning and operation, enabling reduced energy consumption and CO2 emissions. The future of farming is sustainable and smart. KAUST researchers are using flexible, lightweight, easy-to-install thin-film panels as solar screens and semi-transparent solar cell windows on greenhouses to both optimize plant growth conditions and generate electricity. Emerging sensors and remote sensing tools offer an improved capacity to track and monitor water use and account for the carbon generated. Self-cleaning solar panels are used in arid, dusty regions to ensure power supply. Fresh vegetables are grown using salt water via technology that reduces typical greenhouse cooling requirements and ensures efficient plant growth. Organic waste is recycled for desert agriculture, increasing food security while significantly reducing water consumption and pollution to fight desertification and climate change. Decarbonizing the atmosphere to recarbonize the biosphere. KAUST researchers are seeking to exploit nature-based solutions to reduce atmospheric CO2 levels while enriching terrestrial and ocean ecosystems, focusing on a blue carbon approach via mangrove and seagrass restoration projects, on recycling CO2 with bacterial systems, and on algae farming. These solutions target both climate change mitigation and adaptation. Redefining CO2 as a valuable material, KAUST researchers are reusing CO2 in combination with green hydrogen to produce e-fuels that can be used for sustainable mobility, the conversion of renewable energy to formic acid, and catalysts that can turn CO2 into useful platform chemicals for fuels, such as methanol and syngas, can provide a blueprint for the gas station of the future. Green and blue ammonia are also explored as carbon-free fuels. And together with McLaren, we're investigating e-fuel formulations for Formula One cars. Carbon capture and storage are essential to manage down the impacts of atmospheric CO2 levels. KAUST researchers are helping to reduce the CO2 reaching the atmosphere and looking to remove CO2 that has already accumulated there, Novel materials and processes address capture directly from the air and at point of emission sources. Storage via geo-based solutions, including basaltic rock chemistry. Use for enhanced oil recovery and for geothermal energy transport are also key. The Kingdom of Saudi Arabia has created its own National Circular Carbon Economy Program. KSA and 195 other parties have signed the Paris Agreement to lower CO2 emissions by reducing, reusing, removing, and recycling carbon. We at KAUST are doing our part to contribute to this at a national level by supporting the Kingdom of Saudi Arabia in championing their CCE program. KAUST's Circular Carbon Initiative aims to fill the innovation gap through multidisciplinary research and development. We welcome you to the KAUST Circular Carbon Initiative, and we invite you to join us in discussing and exploring ideas to further advance the Kingdom by improving the health of our planet.